Python is the world's most popular programming language. It is a major tool for AI and data science. It runs the databases of basically every large project, and it can be used for app development, games, robotics, home automation, and loads more. Python is basically everywhere, and mastering it is a good path to interesting jobs and a high income. And in this course, you will master it by making games. We will use Python to first recreate the Google Dinosaur runner. And after we have that, we create a fancier 3D version of it. Once you get through all of this, you have a strong understanding of Python, object-oriented programming, how to manage your projects, and an introduction to game development. And if you like these games, there are a lot more. These 2 games are part of a larger course of mine, where we make 6 games in total. We first make the 2D and the 3D runner. Then we create a Zelda-style adventure game, for which we have a proper level, lots of enemies, and fancy animations. This game was also created in a level editor, so you can change it. Next, we remake the Pokemon battle system. For that, we have to work with lots of data and present it by making user interfaces. Once we have that, we can remake a Doom-style first-person shooter. This one has lots of weapons and enemies and feels incredibly satisfying. Finally, to finish the course, we will recreate Minecraft. And this one will be created with the help of AI, which is an incredibly powerful tool to speed things up and help you code. By the end of this course, you will know Python, and more importantly, you will know how to use it well. If you can make a game with lots of moving parts, you can easily switch over to working with databases or AI. And you will also know how to use AI yourself to get results faster. This course is for everyone. There are no requirements besides having a vaguely functioning computer. I will cover Python from the ground up. That being said, if you already know Python and you just want to make games, you can skip the introduction to Python and straight into game development. You can get this course and all of my other courses on my Patreon for £5 a month. Alternatively, you can also get it on Udemy for $10 to $20, depending on their promotions. Other than that, I hope you enjoy. Before we can jump into game development, we have to talk about how games work. In the most basic sense, a game draws a lot of frames, and our brains interpret that as movement. For example, this might look like a moving dinosaur, but in reality, we simply draw 30 frames of a dinosaur and change its position for every individual frame by a bit. Movies work in the same way. The only difference is that they have predetermined frames, while games generate them dynamically. This means that before a game draws a single frame, it checks for a lot of variables. It looks for player input, enemy movement, collisions, timers, and a lot more to determine what should be drawn and where it should be drawn. That is it. A game is just a series of images where each individual image is dynamically created from a bunch of data. In more technical terms, in Python, all we need to do is run a while loop, collect things like player input, collisions, and enemy movement, and then draw a frame. If we do this over and over again, at least 30 times a second, we get a game. As a consequence, a Python game dev module doesn't have to do that much. It fundamentally just needs to draw images and get player input. Python has loads of modules for that. The one that we are going to use is called Raylib. This one can easily draw images and get input. Beyond that, Raylib can also play audio files, check collisions, draw 3D models, and loads more to make game dev easier. It's a really powerful module that people have used to make 2D and 3D games. You can install it via pip in the PowerShell or on the terminal. Just type pip install Raylib on Windows or pip3 install Raylib on macOS, and the rest should happen automatically. Once you have that, you can make games. And besides that, Raylib has a really good documentation. You simply have to go to raylib.com and then you get a ton of info. You have examples, games made in Raylib, and most importantly, you have the cheat sheet. In here, you have all of the methods, functions, objects, literally anything inside of Raylib is in here. For example, for one function, we have a init window, and in there, we have the arguments, or well, the parameters, for the width, the height, and the name of the window that we want to create. This document is really long and contains a ton of stuff. If you ever have any questions about Raylib, you should probably start here. It's super useful. But other than that, this is all we need to get started. So let's start coding. Here we are in VS Code, and if you look on the left, we have 4 folders. We are going to work inside of code. This is where we keep all of our Python files. At the moment, it's entirely empty. Other than that, we have one folder with fonts, one with 2 audio files, and inside of assets, we have all of the images. Like for example, the Dino. There we go. On top of that, there are credits if you want to know where I got the art assets from. Now to get these files, you want to look at the link in the video description. There you can find folders for all of the projects. For the Dino Runner, we want to go to Dino Runner and then download Dino Start Project. Click on the dots and then download. Google Drive is going to think for a second and then you get to download. Once that is done, you should have in your downloads folder in your folder that you want to extract like so in the same folder, and then inside of this folder you get the Dino Start project. In there we have all of the stuff. And this you want to open via VS Code. And for that, here we have a new window for VS Code, and you want to go either to Open Folder or to File and Open Folder. Same thing. Then go to Downloads or wherever you got the folder, and then with the folder selected, click on Select Folder. You don't want to double click the folder, then you get to the folder content. You want to open the entire thing. Select Folder, and there you go. Now you have the Start project. Inside of the code folder, I want to create a new Python file. For the basic version, I want to call it dino_runner.py. And to create this game, we want to use Raylib. As a consequence, we have to import the Raylib library. If you have it installed properly, you can run this code, and you should not be getting an error. So this looks good. Once you have that, you can look at the docs for Raylib and then go through it step by step to create a game. Once again, this document here is going to be incredibly important. It does have a ton of functions, but once you understand the basics, this isn't that bad. For example, to get started, all the way at the top, we can initiate a window. That way, we can see something. Let's try that. Back inside of VS Code, I want to get Raylib and then init window. This we have to call and then give it a width and a height, which in my case are going to be 1280 by 720. After we have those two, we need a title for our game. Let's call it Dino Runner Basic. I can run the code, and then we are getting an error message. That to initialize C-type character, we must have bytes or a list or tuple, not a string. A bit cryptic, but basically, this string here needs to be in bytes. Don't worry too much about it, it's a bit more advanced. Just add a B in front, and then we are getting a window for one frame. And if you look at the bottom, we get a ton more information. This looks much better. Basically now, Raylib is creating a window, and then on the next line, our code ends, so this window disappears. To keep it open, we will need the while true loop. If I simply add pass in here, then the code is not going to end. So if I try it now, we have a window that doesn't stop. Although at the moment, you can't really do anything in here, which is fine for now. If you look at the bottom, you can kill the terminal, and then the entire thing disappears. We're going to make this a bit more elegant in just a second, but for now, inside of this while loop, we can do some drawing, for which you need Raylib and then begin drawing. Make sure to call it, and also we have to add Raylib.endDrawing. Also call this one. Between these two lines, we can draw stuff. For example, we can do Raylib, then draw circle, for which we need a couple of arguments. The center for X, the center for Y, the radius, and the color. Let's say for now, I want to have a center X of 100, the center Y can be 200, the radius can be 50, and for the color, we can get Raylib, and then if you type red, you get a red color. If I now run the project, we're getting a red circle on the left side. Don't worry about the specific position of this thing yet. I'll cover that in a second. And once again, you can't close this project, at least inside of the window. For that, go down here and then kill the terminal. To actually close the project properly, you have to check for some kind of input, which is very easy. All you need is if Raylib is key pressed, for example, then Raylib dot. Now we can check for example for key underscore space. If that is the case, we can print button was pressed. And now I can run the project, press space, and we get button was pressed. The entire thing is fundamentally pretty simple. Now to use that to close the project, we have to find some kind of way to invert this true value. The way you're doing that is you check for while not Raylib dot window should close. And then when you're pressing this one, Raylib dot close window, I can run the project, press space, and the game is over. So all of this would be one of the easiest ways to get started with Raylib. That being said, inside of Python, this doesn't feel elegant. Adding Raylib in front of every function takes a ton of time. And also the naming of the functions isn't Pythonic. All of this is Pascal case, but ideally we want snake case. And for that, Raylib has another library, which is called PyRay. PyRay does pretty much exactly the same as Raylib, except in a more Pythonic way. Once you have that, for example, what you can do is PyRay and then init underscore window in a way that looks appropriate for Python, meaning we can copy all of these arguments, and now we can also just use a string. Once we have that, I can comment out this part, and the code is still going to work just fine. Generally, what you see inside of Raylib is that you import Raylib as RL, so Raylib, and then from PyRay, import everything. That way, we can simply use functions like init window without having to specify where it's coming from. But we know it's coming from PyRay. Inside of this thing, we can do window should close, begin drawing, then we have draw underscore circle, then we want to have the red color. We want to check for is underscore key pressed along with key space. If that is the case, we want to close the window. And finally, we want to end drawing. We can also get rid of this comment. And then the code is looking a lot more Pythonic and much more elegant. So this is generally what you see to use Raylib properly. Sometimes you do need a proper Raylib library, but most of the time in Python, you use PyRay to get the proper function naming. But other than that, PyRay and Raylib do the same thing. If I now run the project, all of this should still work as before, and it does. This looks good. There's just one issue, and that is when we use the key bindings. VS Code tends to complain that those are not defined. This you can fix by accessing the Raylib library directly. When you use key bindings, do raylib.keyspace, and then Python should be happy. And all of this works really well. And well, that's pretty much it. With that, we have the easiest possible code inside of Raylib. And now to practice all of this, I want you to read the documentation and create a line between 2 points. The position of these points can be entirely random. It just doesn't matter. Same for the line thickness and the color. All of that doesn't matter right now. Just read the documentation and try to figure this one out. Pause the video now and see how far you get. Generally, to understand how to do anything inside of Raylib, you want to look at the documentation, and most of the time, it's fastest to simply look for a thing via text search. So in my case, I want to draw a line. And there, we actually have multiple draw line functions. We want to use the simplest one, draw line, where we have a start position X, start position Y, end position X and Y, and finally a color. Right under draw circle, I also want to have draw line. Let's keep the start position of the circle. So 100 and 200 for X and Y. And then we need an end position for X and Y as well, which could be 500 and 800, doesn't really matter. And finally, for the color, let's go with yellow. And now we get a line from the center of the circle to somewhere outside of the screen. That's totally fine. It happens because this value is greater than the height of the window. If I set it to 700, you can see the end of the line. And there we go. Now we have a line. I hope so far none of this is overwhelming. We basically call a couple of basic functions inside of a while loop. And before we finish this bit, there's one more thing that I want to do, and that is to move the circle. The way you are doing that, fundamentally, is to update this position, because when we are running the project, this thing at the moment seems static, but it isn't. We keep on redrawing this thing over and over again, which means when we are changing this position dynamically, it is going to be visible, which we can do, for example, by setting an X position of 100. And this I want to use in here, X position. At the moment, this is not going to do anything, so no movement. But what we can now do, before we draw the circle, X position plus equal 1. Then we are going to get a weird result. We do get movement, but well, this looks weird. What happens at the moment is that we are creating a new frame, but we're not getting rid of the last one, which we can do with another function. Before we draw anything, I want to clear the background, which basically means we want to fill the entire window with a color. I am going to go with Ray White, which is a very light gray. And there we go. Now we have movement. To make this slower, we can set this to 0.1, which isn't going to work yet because if you run it, we get a type error and integer is required. Draw circle wants to have an integer for these positions. That's totally fine. We can simply convert the X position to an integer, and then we get much nicer movement. Doesn't look great yet, but we're going to work on that later. Now that we have the basics, we can do something slightly more interesting, which for now is going to be importing one image and moving it around on the screen. That is already getting us much closer to a proper game. Although before we get to that, there's one thing I do want to cover, and that is the Raylib coordinate system. To understand that, you have to understand that the origin point is in the top left. So here's our window, and in the top left, we have the origin point, so this is 0 and 0. Any positional value that we define is going to be relative to this point. For example, when we created this circle 100 pixels from the left and then 200 pixels from the top. Combined, we are ending here. We defined the center of the circle and then a radius and a color. And when we made the circle move to the right, we increased the X value on every single frame. Now, in high school, you most likely learned about a coordinate system that started in the bottom left, which means going to the right means you want to increase X, and if you want to go up, you have to increase Y. In Raylib, we're doing pretty much the same thing, except that the Y-axis is inverted. If you want to go down inside of Raylib, you have to increase Y. If you want to go up, you have to decrease Y. This does feel a bit counterintuitive, and it's going to take you some time to get used to it. That being said, basically any game engine works like that, so you might as well get used to it. With a bit of practice, this becomes very intuitive. With that covered, back inside of VS Code, let's play around with the position just a tiny bit more. At the moment, we are setting the position of the circle here. And if we want to be in the origin point, 0 and 0 for X and Y. With that, we are going to be in the top left. So this is the origin point. If you want to be in the bottom right, you have to get these positions. So in my case, 1280 and 720. And by the way, if these values are too small or too large for you, you can totally change them. If I now run it, the circle is going to be in the bottom right, as you would expect. So you can tell, if you want to go down, we have to increase the Y value, which always feels a bit weird, but you do get used to it. This we can use right away for an exercise. I want you to capture keyboard input for the up and down arrow on the keyboard. Use that information to move the circle up and down. See if you can figure this one out. Just to keep things clean, I don't want to get the X position or the X variable anymore. Instead, I want to get a Y underscore position. which for now can be right in the middle of the screen, so 360. This I want to use for a draw circle. With that, we should be on the right side in the middle of the window, and we are. Although I guess we can put this to 1000 so we can see the entire circle. Looks good. I have to get the keyboard input for the up and down arrow on the keyboard. Now we already checked for the space key. So the logic here should be kind of similar. We want to check either is key pressed or is key down. Key pressed will only be checked once, whereas key down will be checked continuously. Just to demonstrate the difference, I want to use is key down to get the up key. We want to get Raylib. Remember, for key bindings, we do need Raylib. And in here, we have key and up. If that is the case, for now, I want to print up. And now, because of key down, if I keep this button pressed, we will see this input continuously. Let me demonstrate. Inside of the game, I can press up, and we can see up is being printed continuously. If I had is key pressed, this would only show up once. So I can press it, and every time we only get a single output. Very often inside of game development, you want to have very strict control over an action happening once or happening continuously. For example, for an attack, you want to make sure that you only attack once. But in our case, since we want to move, we want to check for is key down. And if that is the case, y position plus equal some low value 0.1. Then make sure, since we need integers inside of the draw circle function, to convert this thing to an integer. And with that, I can press up and the circle is moving down. That is because this value needs to be minus equal. With that, I can press up and we get the right result. Looks good. Then I can copy all of this. And now I want to check for key down, for which we want to add 0.1 to the y position. And now I can move up and down, and this works really well. And with that, we have basic movement. Later on, we are going to learn how to refine this kind of input to make it much more elegant. But for now, this will do. There's one more thing that I want to cover in this part, and that is how to import a graphic. Inside of assets, I want to import, let's say, Dino and run0.png. There's run0 and run1 because those we are going to use for an animation later on. But for now, I want to use this one. To import that, before we are running the while loop, I want to store it inside of a variable. Let's call it Dino texture. To get that, we have to call the load texture function, which wants to have a file name. Now, this file name is relative to the entire project, which means we want to go from the top level, so all of this, to assets, Dino, and then run0.png. This is the path that we need in here. As a consequence, the path is going to be assets, then a slash, Dino, that would be this folder, and in there, we want to have run0.png. If you now run the project, there shouldn't be an error message, and at the bottom, you are going to see texture loaded successfully. If you get an error here, double check the file path. If you, for example, miss the .png at the end and run the whole thing again, then you get a warning, failed to open file. You do need a file ending, and you have to have the proper name. Another common error would be that you opened this Dino project inside of another folder. Maybe you have it inside of a games folder. Then you need games at the beginning as well. So check your folders and go through them step by step. Then you get this proper result. Now on top of that, depending on the operating system, you might need different kinds of slashes. Depending on the operating system, forwards or backward slashes are preferred. Now, basically all modern operating systems do this automatically, but sometimes weird things happen, which could cause an error. To avoid that, Python has a really neat function. From os.path, and you want to import the join function. This one creates a path for you with the correct slashes for the operating system. The way it works, let me print the result. You want to call join and then insert the path without the slashes but comma separated. Meaning I want to go to assets, comma Dino, and then comma run 0.png. The join method is then going to return the proper path for your operating system. So if I now run the whole thing again, we get the output with different kinds of slashes. So you can see here, Windows does prefer other slashes for the file path, but it is smart enough to not care. Most of the time, this is not going to be an issue, but I would still recommend use the join method just to be sure. So with that, we get the proper import. The thing that you want to get at this point is texture loaded successfully, along with 48 by 32. That is the size of the image. If that didn't work, check the file path, something went wrong in there. Besides drawing a circle, we also want to draw a texture. And then we need, number one, the texture, which in our case is the Dino texture. Then we need a position X and a position Y, along with a tint color. For now, let's go with 0 and 0. For the tint color, I want to use white. If I now run the project, we get the Dino in the top left. It's very small at the moment, but that's okay. We'll fix that later. Other than that, that's pretty much all you need to draw any kind of image inside of Raylib. You have to first of all import it via load texture, and then you can draw the texture with a position and a tint value. The tint value, by the way, if I change it to, let's say, red, is going to tint the image in a certain color. Not something you are going to use very often, but I guess once in a while, this can be useful. Most of the time, though, you want this value to be white, so you get the original image. We are nearly done. There's just one more thing that we do have to cover. When you are drawing a texture, the position you specify is in the top left. Let me use the circle positions, so 1000 and Y position. If I now run the project again, we get the dinosaur to the bottom right of the center of the circle. The center of the circle is this point, and the outline of the image is roughly this. And from that, you can tell that we are placing the top left of the image. This can sometimes be a bit confusing. Always keep it in mind. But other than that, make sure that Y position for the texture is inside of the int function, and then we can move the dinosaur around. This looks pretty good. At the moment, our dinosaur is just a tiny bit small. Let's work on that. While we are doing that, we can also work on rotations and vectors. Really important concepts. Now, to make all of that work, you have to understand that inside of Raylib, there are usually variations of the draw functions that we have used so far. For example, we have used drawLine to draw a single line. But besides that, we also have drawLine V and drawLine X. Those fundamentally do the same thing. They draw a line. However, depending on the function, you can specify things. For example, using drawLine V, you're using vectors for the start and end position. And with drawLine X, you still have vectors, but you can also specify the thickness and the color. Basically, every method inside of Raylib has a couple of variations. Understanding all of those is going to be really important. Back in the documentation, we can also look at the raw texture. There you can see we have even more variations. We have the basic version, then we have the vector version, X, rec, row, and npatch. All of these draw a texture, but they do it in different ways. For example, via draw texture X, we can specify the texture, the position, the rotation, the scale, and the color. And via draw texture rec and pro, we can even cut out specific parts of the texture. Now, before we start coding, there's one more topic I want to cover, and that is vectors. Vectors are super simple. They're just a list with a limited number of items. We have a vector 2 and a vector 3. A vector 2 has x, y values, a vector 3 has x, y, z values. Most of the time, when people write them down, they use square brackets and then the x, y value. For example, a vector could be 1 and 2. This can be quite useful. For example, you can use it to store data like positions and directions. In 2D, those only have x and y values, so vectors here are super useful. In 3D, we would use the vector 3. On top of that, vector math can simplify your life a lot. For example, if you multiply a vector with some kind of number, let's say 2, then the result is going to be a new vector where both values were multiplied, meaning the result here would be 2 and 4. Inside of a game, for example, this could be the direction, this could be the speed, and then this would be the velocity. And all of that is super manageable. And with that, we have vectors. Let's use them. Back inside of VS Code, I want to change drawLine to drawLine vector, for which we need two vectors, a start and an end position, which we can create as a variable in the beginning. I want to have a start position, which is going to be a vector 2. Now we need an x and a y value. Let's go with 10 and 50. After that, we need an end position, which is also going to be a vector 2. I guess now we can go with 600 and 700. After we have these two vectors, I want to change drawLine to draw underscore line underscore b. And now we need a start position, which is going to be a vector 2. So start position. Then we need the end position. And finally, we need a color. Let's go with something more visible, brown. If I now run the entire thing, we should get a brown line, and that looks pretty good. Although it's still very thin, and the line thickness cannot be controlled via drawLine v. For that, we would need, let me get rid of it, we would need drawLine x. In there, we still need a start and an end position via vectors, meaning I still want to use my start position, my end position. But now we can specify the line thickness. Let's go with 10. And finally, we have the color. Let's stick with brown. If I now run the entire thing, we get a much more visible line. So in practice, you basically want to look at different functions and figure out what you need them to do. Understanding all of that is really important. So let's practice it. I want you to go through the docs and scale up the dinosaur. Pause the video now and see how far you get. Inside of the documentation, we want to look for some kind of scale. Draw texture doesn't have that. Draw texture V also doesn't have that. However, then we have draw texture X, and in there we have a position, rotation, and a scale. This is what we need. Which means, when we are drawing the texture, I want to get draw, texture, and then X. For which, let me get rid of all of these arguments and redo the entire thing. Number one, we need the texture. That part is easy, Dino texture. Then we need a position, which could be a vector 2 right away. To be in the center of the screen, we want to have 640 and 360. I divided both of these numbers in half, which would put the top left of the dinosaur in the center. Wouldn't be the perfect center, but close enough. After that, we need a rotation, which for now is going to be 0. We need a scale. Let's go with 5. Finally, we need the color tint. This should be white. And then I can run the project, and we get a much larger dinosaur. The other stuff also still works, so this is looking pretty good. And by the way, this vector can still be connected to the circle position. We simply have to get, for the y position, the y position that we are updating here. This is still going to work just fine, so this looks good. And for rotation, you would change this value, let's say to 90 degrees, and then we have rotated the dinosaur this way, which we could also animate. Like we have done before, I want to check if is key down with RL dot, let's say, key right. If that is the case, I want to increase this value, for which we will need, let me put it below here, Dino underscore rotation. The default value is going to be 0, but when we press right on the keyboard, Dino rotation plus equal 1. And then we can use it in here. If I now run the code, we get a very, very fast movement because we are rotating way too fast. The issue we have at the moment is that this game is very easy to run. So your computer is probably generating at least 1,000 frames per second. So even a very small change is going to be applied many, many times. I can actually demonstrate. After we finish drawing, I want to print get FPS, short for frames per second. If I now run the project, we are going to get somewhere between 2,000 and 3,000 frames per second. This number means that if I'm pressing key up, we are applying this operation over 2,000 times per second. Now, for the proper game, we are going to learn how to work with these numbers a bit better. But a very easy solution to this would be to limit the frame rate, which you can do before the while loop. Let's do it right below init. Set target FPS. In here, you can set a frame rate that the game shouldn't exceed. If I do that, then we are sticking to 60 frames per second. If I now press right, then the dinosaur is going to move much nicer. I can also still do up and down, although now the circle is going to move very, very slowly because we don't have that many frames anymore. So this operation isn't doing that much. Let's change them to a 2. And now this feels much better. And there you can see we get some pretty funky results. The next topic we have to work on are going to be collisions. Those are essential for pretty much any video game. And Raylib, if you check the documentation, has quite a few collision methods. The easiest one, I think, is check collision circles. This one checks 2 circles, one with a center and a radius, and a second one with a center and a radius, and then it returns a Boolean value. It's going to be true if there's an overlap. Back inside of VS Code, we already have a circle. Let me add a bit of white space. This one here. In this circle, we can also move. That makes our life quite a bit easier. Besides that, I want to have another circle. So draw a circle once again, for which we want to have the same x value, 1,000. And this circle should be, let's say, at the bottom of the screen, 600. Then we need a radius. Let's go with 40. And finally, a color blue. Let's try. And there we go. We have 2 circles. And now we want to check if those 2 are overlapping. And while we are doing that, I don't want to print the frames per second. That part isn't needed anymore. Instead, I want to check collision circles, for which we need the position and radius of both of the circles. And for that, we will need vectors. The first circle is going to be a vector 2, where x is going to be 1,000, and the y position is the y position that we have created earlier. These 2 values. Inside of the vector, you don't need the integer. All of that is handled by the vector itself. Then we need the radius for the first circle, that is 50. Then we need the second center. That is in these 2 values, for which, once again, we need a vector 2 with 1,600. And finally, we need the radius, 40. This function is now going to return true or false depending on these 2 circles overlapping. Let me print the result. Right now we get false, but once we get an overlap, we have true. And that is pretty much it. With that, we have a very basic collision. Let's say to make it do something, we could define a target circle color, which by default is going to be blue. But then, before we are drawing the circle, we want to check if all of this is true. Let me cut it out and paste it here. If this condition is true, then target circle color should be green. If it is not, however, else, then the target circle color should go back to, I think I said blue. Yeah, blue. Like so. And then when we are drawing the circle, we want to use the target circle color. With that, once we get an overlap, the color changes. And there we go. We have a collision. Now this is quite useful, but most of the time, you are going to use the first method, check collision rectangles, where you create two rectangles and then check their collision. Especially when you're working with textures, this method is incredibly useful. To use it, back inside of VS Code, let's say we want to check the collision between the texture and some other rectangle, which we can create by draw rectangle, for which we need an XY position along with a width and a height. Let's say I want to create a rectangle from X position 200 and Y position 100, where the width is 400 and the height is 200. For the color, we can use gray. And with that, we get a rectangle that at the moment the dinosaur cannot reach. So let's make this thing a bit wider, and it should be stuck to the top of the window, so Y0. That is much better. Now we have a texture and a rectangle, and we want to check them overlapping. We want to check collision recs, in which Raylib wants to have two rectangles. Those we have to create manually. This could be inside of a separate variable, but it doesn't have to be. You want to have a rectangle, and in there, you need 4 arguments: X, Y, width, and height. For the rectangle we just created, this is pretty easy. We can just reuse these numbers. Copy and paste them, and then you're good to go. But next up, we have to create a rectangle from the Dino texture. Number 1, we need the position, which we get from the vector 2. So in there, we know X is 640, Y is the Y position, which should be an integer. And then we will need the width and the height from the Dino texture. And do be careful here. When we draw the texture, we are applying a scale of 5, which means we can get the Dino texture and the width, but we have to multiply it with 5, so the rectangle and the drawing line up. The same thing we can do for the height, so Dino texture dot height multiplied by 5. And with that, we have all that we need. Let's store the return value inside of a variable rec collision. And then on the next line, I can print the rectangle collision. Right now it's false because there is no overlap, but if I go up here, we get true. So once again, this looks pretty good. Now one thing you do want to keep in mind. Let me copy this rectangle. And then draw rectangle underscore rec. Via this function, we can draw a rectangle from a rectangle right away. All we need is a color. Let's go with red. And then inside of the project, we get a rectangle. Then you can see things a bit better. So now we still get the right outcome to check for collision. The circle also works, so this is pretty good. But if I now rotate the dinosaur, you can see that we have a mismatch between the collision and the dinosaur. So if I did this, the code would think that there is a collision, but the player wouldn't see that. So this is something you want to keep in mind. Working with collisions can sometimes be a bit tricky, but most of the time it's not too bad. Next up, I want to cover sound and text. Once we have that, we pretty much have all of the basic elements for 2D. Although before we get to that, I think we should clean up things just a tiny bit. inside of the game loop, we are getting all of the input here. And this can be done before we draw anything. So I want to get all of this and move it here with a comment input. On top of that, we're getting a bit more input down here. This I want to cut out and then paste here as well. That's already feeling much better. Then inside of the drawing, I want to have some basic drawing bits where we have the circle, the color from the collisions. We are drawing the Dino texture and the rectangle. All of this can be together. And down here, we are drawing a line. This should also be up there. Finally, at the bottom, we have a collision bit. And I suppose this rectangle down here, we don't need at all. That way, we have 3 major sections with input. Then we start drawing. Then we have basic drawing and collisions. Much better organized. Cool. Now that we have that, I want to cover 2 more things, text and sound. Let's start with text. And for that, at the bottom, I want to have text. And as always, inside of Raylib, this document is what you want to start at. Simply look for draw text. There's actually an entire section purely on text. For now, we only care about the draw text function, in which we want to have the actual text, a position, and then a font size and a color. This one is going to use the inbuilt font, so we can't really customize it. That's going to be this function down here, but step by step. Back inside of VS Code, I want to draw text. We need a string. Here is some text. Then we need a position for X and Y. Let's go with 0 and 0, so we're in the origin point. For the font size, I want to have 40. And for the color, we can go with orange. And there we go. Now in the top left, we have some text. That's pretty much it. If you wanted to get dynamic values in here, you would simply have to update this value. For example, we could get an f string and then print the elapsed time, which we can get very easily. Instead of curly brackets, I want to call the function getTime, which is giving us the time since the start of the project. Let's try now. And we are getting the time since the project started. I suppose this one could be an integer, but you get the idea. This one is going to feel much better. And there we go. As always, remember, when you're calling these functions, you don't just call them once. You call them on every single frame. So if you want to update, you simply need some kind of variable that changes over time. The rest should follow along. Besides that, if you want to have a custom font, like for example, inside of the files, we have fonts and retrospace.ttf. This file I want to use, for which we would need draw text and then X. In here, number 1, we need a font, which means we have to import this font before we do anything. So before the while loop, I want to get my custom underscore font, which we can get via load underscore font. All we need in here is the file path, which I want to create via the join method, like we have done up here. Ergo join, I want to go to fonts, in which we have retro underscore space dot ttf. That should be giving us the font. And then inside of the raw text X, I want to have the custom font. Then we need some text. Let's go with custom text. Next up, we need a vector2 position. So vector2, X can be 0 and Y could be 100. Choose whatever you want in here. Finally, we need a font size. Let's go with 30. Spacing can be 1. For the color, I guess we haven't used purple yet. If I now run the thing, we're getting a different kind of font. Might be a bit small. Let's go with 40. That's a bit better. Later on, when we are using this one, it's going to be a bit easier to see. But the important thing at this point is that we have used a custom font, which is pretty simple. All you need is to load it via load font, and then further down here, we can use it like any other function. That being said, there's one additional thing. And while I'm doing that, let me comment out the default text. We don't really need it. Let's say I want to draw this text right in the center of the screen. Or in other words, if I run the project, this text should be centered in the middle of the screen somewhere at the top. This at the moment is actually a bit difficult because this vector 2 places the top left of the text. Just to demonstrate, I know since the screen width is 1280, the center on the x-axis would be 640. If I do that, then you can clearly see that this is the center, but the text is not centered because we are placing once again the top left. To fix that, we have to subtract half of the text width, which we can get. Text width. And this we can capture via measure text and measure text x. The difference between these two is that measure text x can capture a custom font, which we do need. So in here, we need the custom font. We need the text that we want to render, in this case, custom text, the font size, 40, and spacing, 1. This is then going to return, let me print it, not just the text width, but the entire text size. Meaning we're getting a vector 2, which would include the width and the height of the text. Now in our case, we only care about the width, so x. If I print that, we are getting 243 pixels. That is the width of this text. And now that we have that, to center this bit of text, we want to subtract text width divided by 2. And then the text is perfectly centered. When you're working with fonts, since you always place the top left, using measure text x is actually really important. So these two usually go together. But other than that, that's pretty much it for text. Fundamentally, it's pretty simple. Which means next up, we can work on sound. For which, number one, we have to import an audio file. Inside of this thing, we have two, a jump sound and a background music. Those actually work different inside of Raylib. Or to be a bit more specific, you have two sound systems. One for playing a sound once and another one for playing sound continuously. Number one, I want to import the jump sound, which we can get via load sound. Once again, I want to use the join method, go to the audio folder, and in there, I want to get jump.wav, which needs to be a string. This would be pretty simple, although we do need a bit more, but to demonstrate, I want to comment out this print statement for direct collision. So we can see the import messages. If I now run it, we do get data loaded successfully, so we do have an audio file. But then we have a couple of warnings that something didn't work right. That is because we didn't initialize the audio device. Besides initializing the window, if you want sound, which you, basically always want, you also have to init the audio device. Once you're doing that, Raylib is going to be much happier, so let me rerun the project. And now we get the proper loading behavior. Can be a bit annoying, but always remember, besides initializing the window, if you want sound, you need this line as well. It's not being run automatically. But other than that, let's say I want to play the sound if is key rest with Raylib key underscore A. To play a sound, all we need is the play sound function along with the sound that you have imported. So in my case, jump sound. Run the thing. And now if I press A, we get a jump sound. That's pretty much it. So you have to initialize the audio device, load the sound, and then play the sound. That would be for sounds you only want to play once. Besides that, we can also have, let's call it music. And this we want to play continuously. For which we have to load a music stream with the file name. So in my case, this is going to be join audio. And then I want to have music.mp3. This file here. This I want to play continuously, which we can do right away. Play music stream along with the music file. That being said, if I run the code now, this is not going to do anything. Let me demonstrate. We do not get music. That is because when you have a music stream, you have to update it on every single frame, which you probably want to do right at the beginning. You want to update the music stream along with the file music. And now we should be getting music. Cool. And with that, we are pretty much good to go. We have single sounds and background music. In fact, at this point, we have all of the basic elements that we need to make a game. So I want to do a larger exercise. I want you to create the basic game, for which we want to have the dinosaur on the left, and this one is going to jump when space is pressed. Don't worry about animations yet, that's going to come later. Just have the dinosaur texture. The background should be white with a line for the ground. Just draw a straight line in the background. That's all you need. On top of that, have a single cactus or enemy, whatever you prefer, starting on the right and going left, and check for a collision with the player. Finally, display a score at the top, and this one should display the elapsed time since the start of the project. Also use the font that we have imported so far. That should be quite a bit. Pause the video now and see how far you get. Okay, we have a lot to do. Now, while I'm going through this, I am going to disable the music stream so you can hear me talk while the project is running. And then we have to go through things step by step. Number one, I want to work on the dinosaur. This one should be vaguely here, and then jump when we have space input. And to make this a bit easier, I want to have, before the while loop, a section for the game variables. I want to have a dino underscore position, which is going to be a vector 2. In here, I went with 100 and 300. This would be the starting position of the dinosaur, which we can update right away. We are drawing the dinosaur here, for which we want to have the dino position. Let's check. And that looks all right. Besides that, I want to have a floor line. This is going to define where the floor is, and in my case, I want it to be 500. Effectively, this is the border that the player cannot go below. Since we want to have jumping, we also need gravity. That's going to come in a second. Although I think before that, I want to create the basic floor line. We are already drawing a line here. This I want to reuse. The start position should be a vector 2 that goes from 0 on the x position and the floor line. After that, for the end position, I also want to have a vector 2, except now we want to go to 1280, also on the floor line. The color for this one should be gray. With that, we are going to get a straight line, which is looking a lot better. But importantly here, one thing I haven't mentioned yet is that this line is going to be on top of the player because we are calling this line after we are drawing the dinosaur. And Raylib draws stuff in order. So first we're drawing the circle, then we are drawing this circle, then we are drawing the dinosaur, then a rectangle, and then the line. As a consequence, the line is going to be on top of the dinosaur, which is not a good experience. To fix that, I want to draw the line right after we are clearing the background. So it's always going to be in the background. And also at this point, we don't have to draw the circles at all anymore. This one can go, and we don't need the rectangle. That's going to clean things up a lot already. Let's have a look. And that looks better. Once we have that, the dinosaur should be falling down and have the ability to jump, for which I want to have a velocity of the player, which by default is going to be 0. And besides that, we can have, let's call it gravity, which I have set to 0.8. And then, before we start drawing, I want to have a player movement in which I want to get the velocity and on every single frame add the gravity to it. And after we are doing that, dino position.y. So inside of the vector, we can grab individual bits, x and y. In our case, we only care about y. And to that, I want to add the velocity. That way, the dinosaur should be moving down. And it does. Looks good. The problem is that the dinosaur never stops falling. To fix that, I want to add an if statement. If dino position dot y is greater than the floor line. If that is the case, dino position dot y should be equal to the floor line. Let's try now. And that feels a lot better. Keep in mind here, when we are checking for the dino position, we are checking the top left of the dinosaur. That is the only point that we care about inside of dino position, which at the moment looks a bit weird because the background is a bit too high, I think. But that we can fix easily inside of the floor line. So this one, we can give it a bit of an offset. I added 120 pixels, which looks a lot better. After that, I want to check for player input so that we can jump, which we want to do with key space. Let me copy this one and paste it here. We don't want to close the window anymore. Instead, I want to set the velocity of the player to a negative value, minus 28. And that should already do something. So now we have a basic jump. Basically, we always add a small amount to the velocity, and this is going to update the player position. But if we are pressing space, this velocity is going to be a negative value. That is going to go down because of this line where we're adding the gravity, but it does take a while. And while this value is negative, the player is going to jump. And while this is happening, we also want to play the sound. Copy this one, paste it in here, and then we don't need this if statement anymore. In fact, we don't need any of these if statements. All of this can go. That feels much cleaner. Let's try. And all right, we have a jump. I guess before we come to the collisions, I also want to work on the text. And we don't need this comment either, or this print statement. We can clean up quite a bit. We are already drawing the text, basically in the right position. I just want to change the color. This one should also be gray. Let's have a look. That looks pretty all right. The only thing I want to change is this shouldn't be custom text. It should be score and then the get time function, for which we need an f string. But do be careful here. This is going to change the width of the text. So this function also needs to be updated. I think the best way to approach that is to start with the score string individually, in which we want to do all of this. And then we can use this string here and here, which should fix the entire thing. Let's try. Almost correct. We just don't want to have this many decimal points. So this should be int get time. And now this looks much better. Finally, we need one more thing, and that is the enemy. Although before we get to that, we can get rid of quite a few variables. We don't need this one, this one. We don't need the start and end position, the target circuit color. We just need these things, and I think inside of the dinosaur, dino rotation should always be 0. And for the rectangle collisions, we can comment out things for now. The rest should still work, and this looks good. Cool. Finally, I want to import one enemy or cactus. So inside of assets, we have the enemy dinosaur, this one, or we have a cactus, this one here. Import whichever one you prefer. It doesn't really matter. Let's say I want to go with a cactus, for which we want to have a cactus texture via load underscore texture. And with the join method, I want to go to assets. Then I want to get the cacti. And finally, I want to get cactus 0.png. Just to double check, let me run the project. And somewhere in there, cactus.png loaded successfully. That's a good start. Once we have that, I want to draw this texture. So draw texture. Make sure you use X in here because we have to scale the cactus like we have scaled the player. which means I want to have the cactus texture. Then we need a position, which for now can simply be a vector 2 with, let's say, 1,000, so we're on the right, and the floor line. For the rotation, I want to have 0, but for the scale, we need 5. The color is going to be white, and with that, we have a cactus. This cactus we now want to move left, for which we have to update this value. All of this can happen before we are drawing anything, so in here, I want to have the cactus logic. Or I guess since we can have cacti or enemies, this should rather be obstacle logic. Fundamentally in here, we want to get a cactus position and move it left, for which we will need cactus x position, which by default is 1,000. And on every single frame, cactus x position minus equal, let's say 4. Then this value we want to use down here. With that, the cactus is going to move left and we can jump over it. We might have to fine tune the speed here. Let's go with 8. But you get the idea. For now, this is fine. For the actual project, we are going to have better movement. So don't worry too much about it. As long as it works, you are good to go. The last thing that we need are going to be the collisions between the dinosaur and the cactus, for which I want to use rectangle collisions. And I think the best way to start with that is to get the Dino rectangle, which is going to be a rectangle with x, y, width, and height. Now the position for the dinosaur is pretty simple. We simply want to have dinosaur position.x and dino position.y. The width is going to be dino texture.width. And remember, we are scaling the entire thing by a factor of 5. And the same thing we are doing for the height. So I can copy all of this and then get the height. That would be the dino rectangle. And let me hide the sidebars so you can see the entire line. Next up, I want to have the cactus rectangle, which is going to work in pretty much the same way. I want to have a rectangle where we are getting this vector 2 position, which means we want to get cactus x position and the floor line for y. The width is going to be the cactus texture.width times 5 and the cactus texture.height also times 5. And with that, we have the 2 rectangles for the collision, which means we can check if check collision rectangles with the dino rectangle and the cactus rectangle. If that is the case, we want to close the window. Then we can delete all of this stuff and the game should end once we have a collision. Let's try. Cool, this worked. Although, if you only have close window, if you look at the bottom, we do get a warning that the library has not been initialized. That is because we are only closing the window, we are not uninitializing Raylib, and this can sometimes cause a few issues. Ideally what you do is instead of close window, is to call exit. And then the game closes much more elegantly. There we go. Now it's just over. And also I can jump over the obstacle. And there we go. Now the collisions here are a bit rough. So jumping over it is going to be quite difficult. That is because we are creating a rectangle where we have lots of white space. So the corners of the dinosaur and the cactus could cause some issues. In the proper project, we are going to check collisions via circles, which is much more forgiving. But for now, that's not really an issue, and we have made a pretty good basic project with about 50 lines of code. If we enable the music, we just need one more thing, and that is to spawn cacti continuously. That's going to be the next part. We are nearly done with the game. There's just one more thing to do, and that is to spawn obstacles continuously. The way you want to think about that is we are going to create a list and then add a vector to it every few seconds. Each of those positions is going to represent one cactus, or rather an obstacle to be a bit more specific, but you get the idea. After we have that, we are going to go through the list and move every single vector a bit further left. That way, we get movement. That is going to give us all of the new positions, and that we can use to draw all of the obstacles. This sounds a bit complicated, but it's actually pretty straightforward. Let's jump right in. Number one, we need some kind of mechanic to run code, let's say every 3 seconds. For that, I want to have a cactus timer, which by default is going to be 0. On top of that, I want to have a cactus interval. This is how often this thing should trigger. I'm going to stick with 3, which is a pretty random number. It just felt good. After that, inside of the obstacle logic, for now, I want to get rid of this one and instead increase the cactus timer by some small number. 0.02 just felt right. And then I want to check if the cactus timer is greater than the cactus interval. If that is the case, I want to set the cactus timer back to 0 and for now print create obstacle. Writing that, I realized this should have rather been called obstacle timer, but well, since I'm working with a cactus, it kind of works. Change it if you like. Once we have that, I can run the project and we should be getting something every few seconds. Create obstacle, and this works multiple times. Looks pretty good. And this we now want to use to create a new position inside of a cactus list. I suppose this one could be called obstacle underscore list, which is for now simply going to be an empty list. And every time this if statement triggers, we want to add a value to it. Obstacle list dot append, and now we want to append a vector 2, where the x position is 1280, so we are to the right of the window, and we want to be on the floor line. Just to demonstrate what we are getting from this, I want to print the obstacle list, run the project, and now we get 1 vector. Next up, we should get 2, and this is going to continue. There we go. We always get another vector, and each of those would be 1 obstacle. I suppose for now, we can place this position at 1000. To that, I want to add get random value between -100 and +100. So you can see when we have multiple. Then we don't have to print the list. And now we want to draw a texture for every single vector inside of the list. We do not want to draw this individual cactus anymore. Instead, I want to have a for loop. For obstacle in obstacle list. We still want to draw the cactus texture, except now this vector 2 is going to be the obstacle, the value that we're getting from inside of the list. Remember, this obstacle is a vector 2 position. I suppose we could name it better. This should rather be obstacle position. The other 2 values are still just fine, which means if I now run this, by default we get nothing, but we should be getting a cactus after a second, and then a second one, and a third one in a bit. There we go. This looks pretty good. So now we get more and more obstacles. And to move all of them left, after we created them, I want to have a for loop for obstacle in obstacle list. And once again, this is going to be a position. I want to get the obstacle position, and remember, this is a vector 2. As a consequence, we can target the x value and change it by doing -=8. With that, the cacti should be moving left. And they do. This looks pretty alright. And that's kind of the basic idea. Now we have cacti that are spawning continuously. The only change we have to make is that the start position should be 1280, and we don't need the random value, which, by the way, we're getting from Raylib. It does have a few functions for random numbers. So anyway, with that, we can create obstacles continuously. The last thing we have to do is to update the collision. Because so far, we're using the cactus rectangle, and this one doesn't work anymore. This part is going to be your exercise. I want you to update the collision logic so that we check collisions with every single obstacle. If there is a collision, end the game. Pause the video now and see how far you get. We can keep the Dino rectangle. This one still works. But since we now have multiple obstacles, we need a for loop. For obstacle underscore position once again in the obstacle list. Now I have to get a new rectangle. I suppose we should rename this to obstacle rectangle. Feels a bit better. And then we need a rectangle from every single position from inside of this list, which basically means we have to get a new XY position, but the width and the height still works just fine. And luckily, since this is a position, we can still use the obstacle position.x and the obstacle position.y. After we have that, obstacle rect is going to replace the cactus rectangle, and this if statement should be indented. So right after we have the rectangle, we are checking for a collision. Stuff should be working again. Let's wait for a cactus, and if we collide, the game is ending. I can try to jump over the first one so that we can try the second bit. And now, if I collide, the game is still ending. Looks good. And with that, we have the basic project. This is pretty much the most basic game that you can create inside of Raylib. That being said, this project should be improved in a lot of different ways. Most importantly, we should be using classes and objects to organize the code. That would make it much more readable. On top of that, there are a ton of assets that we haven't used yet. We could also create a better timer. This one isn't really ideal. We could use better colors. We could create more frames per second to make the game look better. There are a lot of things that we can work on. That's going to be the next part, where we keep on using all of these basic functions, but we're going to organize them a lot better, which is going to get more advanced, but it's also going to make the entire project much more scalable. That being said, I am not going to cover any major new part inside of Raylib. So if you want to start with your own projects, you could do it at this point. Just keep on reading the documentation and see what you can create. But anyway, next up, we're going to create this project in the proper way. Now that we have the basics of Raylib, we can work on the proper game. We are still going to use the basic Raylib functions, except now we are going to add a whole bunch of refinements. Most importantly, we are going to use classes to organize the project. We are also going to add animations, proper colors, we are going to import files much more efficiently, and we are going to use much nicer timers. Back inside of Raylib, I am still working inside of the same folder. In there, at the moment, we only have dinorunner.py. This I want to close and instead create a new Python file called dino.py. This would be our main file. So in here, we're going to run the actual game. But besides that, I want to have a second Python file called settings.py. In there, we're going to have, well, all of the settings. For example, in here, we want to import Raylib as RL, and from pyray import everything. And while we're here, I guess we can also do from os.path import join. Besides that, I also want to add the window width and the window height, which are going to be 1280 and 720. I want to have a floor line. I think this one was 450, but choose whatever you think looks good in here. Finally, I want to have a scale for the entire project, and this is going to be 5. Notice here, I am using uppercase letters for everything, indicating that these are constants. They should not change while the game is running. Once we have all of that, inside of dino.py, I want from settings, import everything. That way, all of these are available, and everything that we have imported here is also going to be available inside of dino.py. Which means we could run, for example, init window to create the window, which we don't want to do yet, because I want to create a class for the entire game. And in here, inside of the dunder init method, I want to set up the game, which means we want to call init window, where the width is the window width and the height is the window height. We also need a name, which should be a constant. Let's put it here, game name. I suppose Dino Runner would be pretty good, but small details. Game name, and then we should get the basic window. And just to try, I want to call if dunder name is equal to the string dunder main, which should be spelled in lowercase letters, like so. And if that is the case, we want to create one instance of this class. Hence, game is equal to game, make sure to call it. And then we should be seeing this window for one frame. Let's try. And we do. We get a window for a very short amount of time. To keep it open, we're going to need a while loop, which I want to create inside of a method, define run. Don't forget self in here. And then, while not window should close, we want for now pass. Once we have that, I can call game.run and the window should be staying open. Let's try. And there we go. We have a window that we can't close yet. That's okay. You can close it down here. And with that, we have the game class in which we can set up the game and run logic inside of the run method. We're going to add a whole bunch more methods besides that in here. And then the player and all of the obstacles are also going to be a class. Now, besides that, I want to have a define draw method. No need for custom parameters. And in here, I want to begin drawing and also end drawing, like we have done before. After we have that, we can do all of the drawing operations in here. For example, most importantly, we want to clear the background with a color, for which we can reuse ray white. And then, inside of the run method, I want to draw, and this should be self.draw the entire game. That way, we get the proper project, and now we can also close it. I think I forgot to mention that one earlier. You have to begin and end drawing, and once you have that, you can close the window using the close button, so the X at the top. I also want to draw line X. Inside of the draw function, first of all, I want to draw the background line, for which we need a start position, an end position, a thickness, and a color. The start position is going to be a vector 2 that goes from the left side, so X being 0. And then for Y, I want to have the floor line plus 120. Remember, the floor line is what we're getting here. That would be the start position. After that, for the end position, we need another vector 2. And let me do all of this over multiple lines. That feels a bit cleaner. To get to the right side of the window, for the X position, I want to have the window width and get the floor line plus 120 again. The thickness can then be 10 pixels. And for the color, for now, let's go with gray. Just to try. And there we go. Now we have a gray background line. Although, I want to customize the color a bit more. At the moment, we always work with the default Raylib colors, which do work, but they're also very restrictive. Raylib lets you create custom colors by specifying RGBA values. Those stand for red, green, blue, and alpha. Every single one of these values gets a range from 0 to 255. And that way, you can mix colors as much as you like. For example, a color with 255, 0, 0, and 255 would be a pure red color that has no transparency. If you have 255 for every value besides blue, then you're going to get a pure yellow color. So back inside of VS Code, this gray color we can replace with color, and then we can specify the amount of red, green, blue, and alpha. For example, if I want to have a pure red color, 255, 0, 0, and then 255 for the alpha value. If I try this now, we get a red color. If I change this to, let's say, 0, 100, and 0, this value specifies green, so we are going to get a darkish green color. And that looks good. If you look around online or use tools like Photoshop, then you have a ton of visual editors that let you create the custom RGB value that you like. But in our case, the value that I want to go for is 83, 83, and 83, which is a grayish color. There we go. Feels a bit more appropriate. Although this value should be inside of settings, I called this one the main color. Keep the color here, and then inside of the project, I want to have main color. Make sure you're saving everything, and then we can run the project. This looks pretty good. Cool. With that, we have the very basic setup. I guess one thing I want to add just for now is set target FPS to 60 frames per second. This we are going to remove later on, so we have as many frames as possible. But for now, I want to keep the game a bit easier to run. Because next up, what I want to create is, inside of the code, I want to create sprites.py. In here, we're going to create all of the objects for the game, like the player, the obstacles, the background stuff, the floor particles, all of that. Most importantly for that, we need from settings, import everything. That way, we have access to Raylib and Pyray. And then, I want to create a class sprite, in which we have a dunder init method that has self, a texture, and a position. Both of these should be attributes, so self.texture is going to be texture, the parameter, and self.pos is going to be the position. With that covered, I want from sprites import sprite. And for that to work, we have to import a texture, which we can do right away. For now, just for testing purposes, I want to have self.sprite. We want to create the sprite class, and then we need a texture. We can simply load a texture like we have done before via the join function. I want to go to assets, Dino, and then get run 0. Assets, Dino, and finally run 0. Don't forget .png. We should do this over multiple lines because next up we need a position, which should be a vector 2. Let's for now go with 100 and 100. The position we're going to change later anyway. Once we have that, I can run the code and nothing happened, but we did load the texture successfully. That's a good start. Now to draw this sprite, inside of the draw method, we could do draw texture. And for this one, since we have vectors for the position, I want to have draw texture x, in which we need self.sprite.texture. The position would be self.sprite.position. Rotation is 0. Scale is going to be scale from the settings. And finally, for the color, we want to have white. With that, we should be getting the dinosaur. And that looks pretty good. That being said, this isn't really elegant. What would be much better is inside of the sprite class, we can add a draw method. In here, we want to call draw texture x. And then self.texture, self.position. Rotation is always going to be 0, and the scale we're getting from the settings, so scale. The tint color is always going to be white, and with that, the sprite class itself can draw, which we can use inside of the main game. Instead of doing all of this, we can simply do self.sprite.draw. And then we have the same result, except now all of the logic is inside of the class, which makes it much easier to use. So this is much more readable. And that way, we have a basic sprite class that can do a ton of stuff. This we want to use via inheritance to create the class, let's call it Dino. This should inherit from the sprite class. And in here, we're going to have all of the Dino logic. Doing all of this is going to be your exercise. I want you to recreate the Dino logic. This is going to include 3 parts. Number 1, get player input. Number 2, add the jump mechanic and gravity, so the dinosaur can go up and down. Finally, play the jump sound when there is input. And for all of that, work inside of the Dino class and use the inherited stuff from the sprite class. Pause the video now and see how you get. Back inside of VS Code, I will need a define dunder init method with self. We will need a texture, a position, the jump underscore sound, and then via super dunder init, we can turn these two parameters into attributes, which means we want to pass through texture and position. Besides that, we also want to store the jump sound as an attribute, which we cannot do in the parent class. So now we will need self.jump sound is going to be the jump sound. We are going to need a bit more stuff in here, but for now, I want to test if this thing is working in the first place, which I want to import the Dino class, and then self.sprite I want to remove entirely because we don't need it. Instead, this should be self.dino via the Dino class, and then we still want to load the texture, get the position, and we will need the sound, for which I want to load the sound and via the join method, get the right file. We want to go to assets. Somewhere in there, we have audio, and the file I want to import is called jump.wav. And then inside of the Dino class, we have all of the basic attributes. And to make sure it's working, I want to self.dino.draw. Let's try. And there we go. We still have the dinosaur. Although by default, I don't like the position. The start position of the dinosaur should be 100 on X and the floor line on Y. That way, we should be down here at the start, and that feels much better. Cool. Next up. Inside of the Dino class, I want to get player input. Define, let's call it update. And here, for now, I want to have self only. And then check if is key pressed with Raylib dot key space. If that is the case, for now, I want to print space bar pressed. This should work, but we do have to make sure that we are calling the update method, for which inside of the game class, besides draw, I want to have define update. And in there, we want to have self.dino.update. If I now run the project, then I can press space and nothing happens, because this update method needs to be called inside of a run. Or in other words, before we are drawing, I also want to self.update everything. And now I can press space and we get space bar pressed. Really important to understand. The only thing that actually runs the game is this while loop. This one runs continuously. In there, we're calling the update method and the draw method. The draw method is drawing everything, and the update method is, well, updating all of the individual sprites, of which at the moment we only have one, the Dino class. And inside of there, we have one more update method, and this is giving us the if statement with spacebar pressed. I think at this point, because we're using classes, the code is getting a bit more complex. Definitely go through this step by step and make sure you understand every single bit of it. But next up, inside of the update method, I want to recreate the jump logic, for which, first of all, we will need a self.velocity, which by default is going to be 0. And then inside of update, I want to have self.velocity plus equal 0.8. And after we have that, self.position.y plus equal velocity. Since we are drawing the texture by using the position, this should already do something. Let's try. I want to run dino.py, and the dino is falling down. Looks good. To make sure we don't fall continuously, I want to add if self.position.y is greater than the floor line, then self.position.y should be equal to the floor line, and self.velocity should be 0. That way, if I run dino.py, dinosaur should not be falling anymore. Looks good. That would be gravity to actually jump when we're pressing space. Self.velocity should be minus 28. Let's try this one. And there we go. We have a jumping mechanic. And while we are here, we can also play the sound self.jump sound while we are doing all of this. Although for that to work, let me run the project again really quick. We are getting warning that the file failed to open. This might be because I did not initialize the audio device. And on top of that, I realized the audio file is not inside of assets, it's a separate folder. So assets shouldn't be there. The file path for the jump sound should only be audio and then jump.wav. With that, I can run the entire thing, press space, and we get a jump sound. This would be a very basic setup for the dinosaur. And before we finish this part, these numbers here should be, at the very least, in the dunder init method. Self.gravity is going to be 0.8, and self.jump, let's call it jump height, is going to be minus 28. After that, plus equals self.gravity, and then down here, self.jump height. You could even place these two inside of settings. But since in this case, the dinosaur is the only sprite using these numbers, it doesn't really matter. We have the very basic setup using classes. And I hope you can appreciate that this is making the game much more modular. Most of the time, you're going to work inside of dino.py. And in there, now, the entire drawing logic is, well, pretty simple. We are drawing a line here, and the Dino draws and updates itself. All the actual logic for that happens in here. So when you're working with the main project, it is much easier to see what's going on. And then when you want to work inside of a specific bit, you just open it and change very small parts of it. Let's animate a dinosaur, which is going to add a ton of character. We don't need any new functionality inside of Raylib. We just have to talk about how animations work in general, which is actually pretty simple. To create an animation, you just have to play the animation frames in a sequence. So for the dinosaur, we have this and this image. If you combine the two, you get a running animation. That's pretty much it. And all of that we are going to implement inside of the Dino class. Although before we get to that, we have to import from assets and Dino run 0, run 1, and the jump PNG. This one isn't going to be animated, but we should still include it. At the moment for the dinosaur, we are only importing a single PNG image. This we have to expand, and for the game more generally, we have to import a ton of assets, which we have to organize a bit better. For that, I want to have define import assets with self, and in here, we want to have self.assets. This will become a dictionary with all of the assets that we have imported. And then we are, for example, going to have the player run animation, for which we still want to use load texture, but we have to use it for two files. We will need run 0 and run 1. These we can import using list comprehension. Let me actually copy what we have done up here. This would import what we have done so far, but now this 0 should either be a 0 or 1, for which we can use an f string. And I want to add an I in here, because since we have list comprehension, we can do for I in range 2. Remember, the range function only goes from 0 up to this number. So we should be getting 0 and 1 here, which is perfect for our purposes. Also, this shouldn't be an equal sign. And also make sure that you're calling self.import assets before you are creating all of the sprites. And just for testing purposes, I want to print self.assets with the player run animation. This should return a list with two textures. Let's try. And somewhere in there, up here, we're getting two textures indeed. This looks good. This would be the first one, and then we have the second one. Not exactly readable, but we know they are there. This we want to add to the dinosaur when we are creating one instance of it. Self.assets with the layer underscore run animation. Pretty much what we have done down here. But this is now going to be a problem because inside of the Dino class, we are expecting only a single texture that we're then passing into the parent. And in here, if this is a list, then this function is not going to work. So if I now run the project, we should be getting an error, and we do, as expected. To overcome that, when we are initializing the Dino class, this should be textures, or to be even more specific, run textures. And those we want to store separately. Self.run textures is going to be run textures. And when we initialize the parent class, I want to have the run textures and 0. So we only pick one file from this list. At this point, you could get the run textures or self.run textures. They would do the same thing. If I now save sprites.py, run the project, the dinosaur works again. So this is a good sign. And now we have two run textures that we want to play in sequence, for which we want to update the draw method. We don't need update. Instead, I want to create define draw. This draw method is then going to overwrite this one. So we have to recreate the functionality. But before we get to that, we have to figure out how to play these run textures in sequence, for which I want to have a self.frame index, which by default is going to be 0. Then we can do self.texture is going to be self.run textures. And remember, this is a list, so we can do indexing. And here, I want to get self.frame index. That way, at the moment, we would always pick the first item. Once we have that, we can call super and the draw method. That way we keep this functionality, and since we now have a texture selected down here, this should work, although it's not going to be animated yet. Let me try. So far, so good. Cool. Now we have to update this frame index, for which fundamentally all we have to do is self.frameIndex plus equal some small amount, let's say 0.1 for now. That way, this number becomes larger and larger, and at some point, we are picking the next item inside of the list. Although this at the moment is not going to work for two reasons. Number one, when you're using indexing, you need to have integers. But since we're doing this operation, we're getting a float, so this would not work. To fix that, we want to have an int function to turn this float into an integer. That way, if I run the project, at some point the dinosaur should change, and it does very quickly. But then we're getting list index out of range because this number keeps on growing. But since this list only has 2 items, if this number becomes a 2, then we can't get the index anymore. One way to fix that would be to simply do if self.frameIndex becomes greater than or equal to the length of self.run textures, then self.frameIndex should be 0. With that, we have the animation. Let's try it again. And now we get a basic animation. That works pretty well. And I hope the logic here makes sense. Inside of run textures, we have 2 PNG files, and we select one of them via self.frameIndex, which in turn increases over time. And if we exceed the length of the list, then we are resetting it to the value of 0. That way, we play all of these images in sequence. If we had more than 2, this would still work. Now this is working, but it's also not really elegant. We can do all of this on a single line. What I want to do is self.frameIndex and then %sign equal. So we are doing a modulus operation and the length of self.run textures. This would be doing the same operation. Let me execute it, and there we go. We still have the same animation, except we have saved one line of code. Now in practice, these two do the same, and I think this one is much easier to understand. But if you understand the modulus operator, then this is a much more elegant way of doing it. Choose whichever you prefer. I'm going to keep the second one, like so. And then we have the basic animation. All we have to do now is add an exercise, and then we are done with this part. I want you to play the jump frame when the dino is jumping. For that, you have to import the third dino image. Then get it into the class and show it when the dino is in the air. Pause the video now and figure this one out. Number one for this one. Inside of assets dino, we have jump.png. This I want to import, which we are going to do inside of import assets. I want to have a second entry in here. I guess we can call it player_jump. We don't need list comprehension because this is a single file. All we need is what we have done before, load texture. We don't need an f string. All I want to do is get jump.png. And for all of this to work, make sure you add a comma at the end of the first key value pair. With that, we have the file that we want to display, and that we have to get into the dinosaur. I suppose we can add a second argument, self.assets, along with player_jump. After that, inside of Dino, besides the run textures, we also want to have the jump texture, which we have to store inside of an attribute. Self.jump_texture is going to be the jump texture. That covers this part. Next up, inside of draw, we have to figure out when to display the jump texture. At the moment, we only played the basic run animation, but we only want to get this run textures if self.position.y is greater than or equal to the floor line. If that is not the case, else, then we want to get self.jump texture. A bit hard to read because my text is quite large, but I think on your monitor this should be much more readable. So in our case, we want to pick one of the images from run textures, depending on what we get from the frame index, but only if the dinosaur is on the floor line. If we are above that line, then we want to play the jump texture. All of this can be done with a ternary operator, although you could also use a normal if statement. Both would work. Let's try. If I now play the game, the running animation works, and if I jump, we get a much better result. The last thing that I want to do is to get load sound into import assets. Besides the assets, we want to have self.sounds, or I guess rather self.audio. Choose whatever you prefer. I want to have a dictionary and then get the jump sound, for which we want to do all of this. And then for the dinosaur, we can get self.audio with the jump sound. That way, all of the imports are inside of a single method. That makes it much more readable. The end result should still be the same. I can jump, and the sound is working. Cool. Before we continue, there's one important thing that we have to cover, and that is delta time. Via that, you can control the speed of the game regardless of the frame rate. And fundamentally, it's a pretty simple concept. It is the time it took to render the current frame. If your game runs at 60 frames per second, then delta time would be 1/60 or 0.017 seconds, which would be roughly 17 milliseconds. And just to demonstrate why we need it, let's say inside of the dinosaur, in the update method, I want to move the dinosaur to the right, for which we would need self.pos.x plus equal some amount, let's say 1. And then, if I run the project, the dinosaur is going to move right. That looks pretty good. However, the problem is that the speed is set by the frame rate. So effectively, at the moment, we are running this while loop 60 times per second, or whatever value you have set in here. Every time we are doing that, we are updating the exposition by this value. As a consequence, the faster this while loop runs, so the more frames we have, the faster the dinosaur is going to run. If I set this to 120, we are going to move twice as fast. And if I comment out the line, then we're going to run really fast. And all of that is a pretty substantial problem because you want to have as many frames as possible. The more you have, the better your game is going to feel. So how can we achieve that without sacrificing control of the speed? Or in other words, how can we make sure that this change of position feels the same regardless of the frame rate? And for that, we have delta time. Let me talk about a tiny bit of math. When we talk about the frame rate and the speed, we are talking about a couple of things. Number one, we have the frames per second. So how often the while loop runs per second. We have 3 versions for now: 10, 30, and 60 frames per second. And in all 3 scenarios, we want to have a pixel movement of 10 pixels per frame. The unfortunate outcome is that the actual movement is going to differ depending on the frame rate. The more frames we have, the more often we are applying the movement change, hence the greater the movement. And this is pretty bad. For a consistent game, these 3 numbers need to be the same. And at the moment, they're not, which is a substantial problem. If there's a 6-time difference between your game, depending on the computer, the game is effectively unplayable. And all of that we can fix via delta time. Let's talk about it. And for that, I want to expand the table. We still have the same frames per second. 3 scenarios with 10, 30, and 60 frames per second. But then we have delta time, which is just 1 divided by the frame rate. So this 10 comes from here, this 30 comes from here, and you get the idea. With that math, we get 0.1, 0.033, and 0.017. We still have the same pixel movement that earlier caused the problem. So these numbers we want to fix using delta time, which looks like this. All we have to do is get the frame rate and multiply it with delta time and the movement that we want. The end result is going to be the same movement regardless of the frame rate, which is exactly what we want. And the reason why all of this works is because delta time is 1 divided by the frames per second. And if we do frames per second, multiplied with 1 over frames per second, the 2 cancel each other out, hence FPS are neutralized. All that's left is the actual movement that we want. And implementing all of that inside of the game is incredibly simple. All we need inside of the while loop, before we are doing anything, although the position here doesn't really matter, we want to get delta time or dt, which we can get with get_frame time. Make sure to call it, and then I can print the result. Delta time, run the project, and we get 0.08 something. That at the moment is because we have set the frame rate to 120. If I set this to 60, we should be getting roughly 0.016, and we do. I did run the numbers, but you get the idea. And really important now, if I comment out this line, so we get as many frames as possible, then we are getting a really, really low number for delta time, because now we have something like 1,000 frames per second, which is totally fine. Since this value is really precise, we can work with an incredibly low number. We just have to use it. And for that, I don't want to print delta time. Instead, I want to pass it into the update method. So delta time in here, and then we need a parameter for delta time, which we want to pass into the update method of the dinosaur in there. And now, if I go to sprites and the dinosaur, in here, we will need delta time. And now to apply it, all we have to do is to always multiply any kind of change with delta time. That way, this number will be independent of the frame rate, which we do have to do in a second for gravity and velocity. But for now, I want to run the project. And now the dinosaur is going to move very, very slowly because delta time is a really low number. So this should rather be, let's say 200. And then we have a change in movement that is going to be consistent. And by the way, when you use delta time, you also have to apply it to any kind of animation, so the stuff we're doing here, and any kind of rotation, which we don't have at the moment. Basically, any gradual change, so whenever you use a plus equal, you want to use delta time. You can actually tell at the moment if we run the project, that the Dino animation is a bit wonky because we're not using delta time. That we can fix by using another constant, animation speed, which I have set to 5. And then, inside of the sprites, I want to have animation speed multiplied with delta time, which at the moment doesn't work because delta time is only available inside of the update method. That's totally okay. Since we are calling the update method before we're calling draw, we can put both of these lines inside of the update method and the entire thing should still work just fine. And now we get really consistent animations. This feels nice. Let me add some comments. This would be the animation. This can go entirely. There we have jump, input. And I guess all of this is going to be gravity. Now, this part we do have to fix, especially these 2 lines. Because inside of the game, if I now jump, nothing is going to happen. Or well, something is happening, but it looks strange. To account for that, number 1, we have to multiply both of these values with delta time. And then gravity is going to be 300. And the jump height I set to minus 400. With that, I can run all of this again. And now we get a much nicer jump. This works pretty well, so I am quite happy. And with that, we have delta time. Fundamentally, a really simple concept. Number 1, you have to get the frame time and then multiply it with any kind of change. So wherever you do plus equal, the value should be multiplied with delta time. This applies to position changes and to animations. However, it does not apply to jumping because in here, we are simply setting a generic value. We are not changing it over time. To spawn all of the enemies and obstacles and background objects, we need to have proper timers. That's going to be this part. Now, unfortunately, Raylib only allows you to measure the time, but not much more. As a consequence, we have to create our own timer logic. Which means we want to have a timer that is customizable and ideally trigger a function when it finishes. To keep things organized, I want to create a new Python file. Let's call it custom_timer.i. And in here, number 1, I want from settings, import get_time. That is a function that we are getting from Pyray, and it measures the time since the start of the project. That's all we need to create a proper timer class, in which I want to have a dunder init method with self. Then we need iteration, and that's all we need for now, although later on I do want to expand it. This duration should be an attribute, so self.duration is going to be duration. Besides that, we're going to need a start time. So we know when the timer has started, and by default, this value is going to be 0. And then the fundamental logic is going to be inside of an update method. No need for any custom parameters in here, but don't forget self. And then we want to check if the timer is self.active, which is an attribute I forgot to add. So self.active, which by default is going to be false. And then we want to check if get time, so the time since the start of the project, minus self.startTime is greater than or equal to self.duration. And if that is the case, we want to print timer is done. For a bit more detail, imagine this is a timeline of the game, where we start at 0 seconds and then the game keeps on going forever. When the timer starts, we're going to set a start time. Let's say this one could be at 5 seconds. This would be this value. And then via getTime, we are checking the time continuously. If we subtract one from the other, we get the elapsed time from this point forward. For example, if the duration is 3 seconds, then this if statement is going to trigger if we get to getTime being 8 minus the start time of 5. This would be greater or equal to 3, the duration. That's basically all we need for a super basic timer. All we need is some kind of way to start it. Let's call it activate. In there, self.active is going to be true, and self.startTime needs to be the current time. So get time. With that, via this if statement, after we have activated the timer, we can check the time that has elapsed since the starting time. And then we can check if we have gone past the duration. And after that, the timer is done. Let's try. Inside of the Dino class, I want from custom timer import timer. And then create one instance of it. Let's call it self.testTimer, for which we need a timer with a duration of 3 seconds. This timer I want to activate right away, so self.testTimer.activate. That way, the timer is going to be active. But really important, we have to call the update method continuously. Otherwise, this is not going to do anything. Which means inside of the update method, self.testTimer.update. And now I can run the project, and after 3 seconds, we should be getting some output. And we do. Timer is done. This looks good. Now, one thing that we do want to refine right away is a deactivate method. Because at the moment, if this timer finishes, we keep on printing timer is done, which isn't ideal. This timer should only trigger once. Which means inside of deactivate, self.active is going to be false. Self.startTime is going to be 0. And then make sure after you have printed the outcome, we want to self.deactivate the timer. With that, I can run the project and we should be only getting a single output. And we do. And with that, we have this super basic timer. But this at the moment doesn't really do anything. For actual functionality, this timer should be able to trigger some kind of function once it triggers. For which I want to add another parameter, which I called callback. Callback usually refers to some kind of function that you want to call when an event happens, which in my case is going to be the update. So this would basically just be a function. But I'm going to call it callback, which we want to store as an attribute self.callback, callback. And then inside of the update method, when this if statement has triggered, I want to check if self.callback exists. So if we have assigned a callback function to this timer, then we want to call it. So self.callback. And now, via parentheses, we want to call this function. And to test all of that, inside of the dinosaur, I want to create, in just a second, a spawn obstacle method, which for now is simply going to print spawn obstacle. And this we want to pass into the timer. So in self.testTimer, I want to get the duration and then self.spawn obstacle. And now after 3 seconds, we get spawn obstacle. That looks pretty good. Spawn obstacle is printed inside of this method, which we are now calling from inside of the timer. Which means we are nearly done. There are just a few refinements that I want to add. All of those are going to be your exercise. There are 3 things that I want you to do. Number 1, add an option for an auto start, so that we don't have to call activate on the timer. On top of that, add a repeat functionality, so that when the timer triggers, it should restart right away. And finally, don't require a callback function when the timer is created. It should be possible, but it shouldn't be required. Pause the video now and see how far you get. Number 1, I want to have an auto start value. All we have to check is if auto start and then self.activate. That was pretty much it. Now, inside of the Dino, when we create the timer, we have to add a third argument. And if this one is true, then the timer is going to activate automatically. I can remove this part, run the project again, and the timer should still do something. After 3 seconds, we still get the output. Besides that, I want to have repeat, which we have to store as an attribute. Self.repeat is going to be repeat. This one is going to be used inside of the activate. In here, I want to check if self.repeat, and if that is the case, I want to activate the timer right away after we have deactivated it. That way, we go back to this bit and we run the timer once again. Pretty simple. Which means inside of the Dino, I can add true for repeat and reduce the duration to 1 second, so we get a few more outputs. And now we are getting spawn obstacle once a second. This works really well. And the final part is going to be that these values for callback, auto start, and repeat should be optional, which we can achieve by giving them default values. Repeat should be false, auto start should be false, and for callback, I want to have none. That way, these arguments become optional, but I guess for my purposes, I do want to keep them. And with that, we have the timer. That's kind of all we needed. Although before I finish, what I tend to do to make the timers a bit more manageable. When you have multiple, I think it's easier to have a self.timers dictionary, in which you, for example, have an obstacle key with the timer that you want to use, like so. Later on, we are going to add multiple timers in here, and all of these we have to update, which happens inside of the update method. To update all of them, all we need is for timer in self.timers.values and then timer.update. That way, any timer inside of this dictionary will be updated automatically. So this should still work. We get the right output. This looks really good. And if I added a second timer in here, let me duplicate all of this. Besides obstacle, I also want to have a background cloud timer, for which we can have a duration of 2 seconds and then create another method, define spawn cloud, which is going to work in pretty much the same way that spawn obstacle works, except now I want to spawn a cloud. Spawn cloud in here. We do want to auto start, and repeat should be enabled. Which means if I run the project, we should be getting obstacle and cloud. That looks pretty good. Cool. With that, we have timers. Now that we have the timers, let's work on the obstacles. For which, back inside of VS Code, I want to work inside of the sprites Python file. Besides the player dinosaur, I want to have another class. I called this one a moving sprite. This one, like the dinosaur, should have the sprite class, so this one as the parent. And then for the dunder init method, we want to have self, at least for now, a texture, a position, and then some kind of speed. To initialize the parent class, we will need super dunder init with the texture and the position. We also want to store the speed, so self.speed is going to be speed. We will need an update method with self and delta time. All that we want to do in here is self.pos.x minus equal self.speed multiplied with delta time. That would be all we need for the really basic setup. To use it inside of the main Python file, make sure that you import the class, so moving sprite, and we don't have to import the sprite class. This one is just there for inheritance. Now, since we want to show a cactus for now, I want to import all of these files. And then we're going to pick one of them randomly every time we are calling spawn obstacle. This is the kind of thing that we have done before. When we had the player run, we imported multiple files, which means now I want to get the cacti and via list comprehension, import the entire folder, which we can do by copying all of this. I want to. load a texture with assets. This should be cacti. And in there, we have cactus from 0 to 3, which means cactus. And for the range, we have to go up to, but not including 4. That way, let me test it. Print self.assets with the cacti. We should be getting 4 files. Here's the list. And in there, we have 1, 2, 3, and 4 different PNG files. Looks good. That means every time we are spawning an obstacle, I want to create a moving sprite, for which we need a texture and a position. The texture is going to be a random cactus, or in other words, a random item from this list. To get that, inside of settings, I want from random import choice. This one picks a random item from a list. So the texture is going to be choice with self.assets and cacti. For the position, I want to have a vector 2 where we are on the right side of the window, so window width. And for the Y position, for now, I want to have the floor line. This is going to create one sprite. On this sprite, we now have to call the draw method, like we have done for the dinosaur, so this one, and we have to call the update method. And to organize all of that, I want to create a self.sprites list. And to that list, we are going to add the moving sprite. Let me store it inside of a variable sprite, and then self.sprites append and the sprite. And after we have that, we can update all of the sprites here and draw this stuff here. In other words, I want to have for sprite in self.sprites sprite.update. Don't forget delta time. And then inside of the draw method, I want to do the same thing except with draw. Let's try all of this now. And we're getting an error message that we forgot the speed argument. That's totally fine. This means when we are creating a moving sprite, besides the texture and the position, we need a speed. And let me do all of this over multiple lines so it's a bit more readable. That's much better. And for the speed, I want to go with 300. Next attempt. And now we get cacti. Definitely too many, but this is working. And notice here, we do get random cacti. So the randomness is also working just fine. That is a really good start. And just to go over the logic one more time. Inside of sprites, we are creating a new moving sprite that is basically the parent sprite class, except now we are updating the position. Whenever the timer triggers, we are calling spawn obstacle, in which we are creating a sprite and adding it to the sprite list, the one we have created up here. After that, inside of the update method, we are calling the update method of every single sprite inside of the list, and inside of the draw method of the class, we are doing the same thing for the draw method. As a consequence, for the moving sprite, we are calling draw and update. And since this timer triggers multiple times, we get multiple cacti. And at this point, we can clean up the code a tiny bit because we are updating all of the sprites and then we are updating the player. These two things we can combine by placing the Dino, so the player, inside of the self.sprites list. All we have to do is get self.sprites and then append self.dino. Once we have that, we don't need this line anymore, and we also don't need this line here to draw the dinosaur. The game should still be working, and that looks pretty good. And I think at this point, we should adjust the duration of the obstacle timer. I think 3 seconds here would be much better. Let's try, and then after 3 seconds, we get a cactus, that we can jump over. Then we get another one that we can also jump over. And this works pretty well. Perfect. And well, that is pretty much the basic logic to spawn obstacles. Now at the moment, we don't have collisions, but that's going to come in the next part. For now, I want to do two more things. I want to have in the background a whole bunch of clouds that also move left, and I want to have floor elements that break up the floor, so we don't have a continuous straight line. Here is how the end result should look like. This part is going to be your exercise. I want you to add more sprites. Add clouds and floor elements. And really important, both should always be in the background. They should never be on top of the player or the cacti. Pause the video now and see if you can figure this one out. Number one, let's start with the clouds. We have to import all of these files, which we've done before inside of import assets. I basically want to duplicate all of this, except now it's going to be called clouds. Don't forget the comma at the end. We want to go to load texture, assets, clouds, and in there we have cloud from 0 to 3. So we want to go up to 4, but not included. That should be all of the assets that we need. After that, we want to spawn a cloud using this timer, which we already have. So inside of this method, we want to create a cloud, which is going to work in pretty much the same way that we have used down here. I can literally just copy all of this because a cloud is effectively just a moving sprite. Hence, we can reuse this one. All we have to change is choice, self, assets, and clouds. For the position, we want to have the right side of the screen, so this one is fine. But on the Y position, I want to get floor line and then subtract, let's say, a random value, which we can get from settings. I want to import choice and random integer. And then floor line minus random integer between 160 and 240. Just two values that I think looked good. And while we are here, for the speed, we can also get a random integer between 80 and 120. After we have that, we are adding the clouds to the sprites list, so they should be visible and update. Let's try. And now we should be getting clouds, and that looks pretty good. That being said, if I reach them in a second, you are going to see a problem. That the dinosaur at the moment is behind them. A bit hard to see, but the dinosaur has a white outline, which we can't see because the clouds are on top of the dinosaur. Although before we get to that, to see the problem better, I want to add another timer, which is going to be for the floor. This one should call a method spawn floor and have true and true for repeat and auto start. Also, the cloud timer should be set to 5. Now, this floor timer is going to be define spawn underscore floor with self. And then, once again, we want to do pretty much what we have done here. Let me copy and paste it. We want to create a sprite and attach it to the sprites list. For that to work, we have to import these floor parts, which we have done before. So I want to duplicate this line, call it floor, and then we want to go to assets, floor, and import floor 0 to 3. So this part still works. For the floor, we want to have a moving sprite once again. We want to go to self.assets and floor. We do want to spawn on the right side and on the floor line. I think a speed of 300 is totally fine. So now let's try. And we should be getting random floor bits, which we have to offset a tiny bit. But first of all, now we can see the problem, that these floor bits are on top of the player, and that's not ideal. Which, by the way, happens because we are drawing all of the elements depending on where they are in the list. And since we add the dinosaur first of all, before we are doing any of the timers here, the dino is going to be first in this list. Hence, it's going to be drawn first, and then we draw all of the other elements, which is okay for the obstacles, because once they overlap, the game is over anyway. But for the clouds and the floor, this is a pretty big problem, which we do have to address. Although before we get to that, inside of spawn floor, I want to have floor line plus 40. Once we have that, this should look much better. And there we go. Now the floor line aligns with the background. Much better. Cool. So, how can we now get the clouds and the floor in the background? I think the easiest way to approach that is to create another sprites list, except this one is going to be BG sprites. Other than that, it's still going to be just a list. And then, when we're creating a floor, I want to add it to BG sprites. Same for the clouds. They should be inside of BG sprites. After we have that, we have to make sure that we are also calling the for loop to update the sprites on BG sprites. For update, the order here doesn't matter, so we can add the two lists together. All you need is self.sprites plus self.bg sprites. Then all of this should still update. But the important part is for the draw bit, because now we want to first draw for sprite in self.bg sprites and sprite.draw. That way, we are first drawing all of the background elements and then the main sprites. So now the dinosaur should be on top. Let's see how this is going to work. And there we go. This feels significantly better. And also you can see the cacti are always on top of the player. But if I now jump over a cloud, you can see the cloud is definitely behind the dinosaur, which is a pretty big visual improvement. So this is quite nice. Now, what you could also do is to comment out all of this and then do self.bgsprites plus self.sprites. The for loop is first going to go over all of these and then these. So the order should still work just fine. Let me wait a second. There we can see a floor bit and the player is still on top. So this does work. It should also work with the clouds. Let's wait just a second. There you can see the dinosaur is on top of the clouds. While this does work, I feel like having multiple while loops is much more readable and, especially for a more complex game, much more secure. But choose whichever one you prefer. Nearly done. I just want to add a few more minor parts. Number one, when we spawn the floor, I want to update the timer, so the floor timer, to be a bit more random, which we can do quite easily. Self.timers with the floor timer, and on there, I want to get the duration. This value should be a bit more random, which I can achieve by get a random value and assign it a value between 1 and 3. With that, we should be getting a floor bit that looks slightly more organic, which I think is alright. Just play around and see what you prefer. The clouds are totally fine, and for the obstacles, I want to have a bit of an offset for the floor line, which we can change by adding the rand int value with a value between -10 and 10. Once we have all of that, the game should be looking quite a bit more organic. A bit hard to see, but inside of the game, this is definitely noticeable. Cool, this works. For the last part, there's one more thing that I want to add. So far, we have spawned 3 different kinds of sprites, for which we always imported some kind of texture and then moved it to the right. Besides that, I want to have a couple of lines below the floor, and these we can generate in code right away. Let me demonstrate. Inside of self.timers, I want to have one more timer. I call this one floor_lines. The duration here is going to be much shorter, 0.2. The method we want to call is spawn floor lines, which doesn't exist yet. So at the bottom, I want to have define spawn floor lines. We want to do the same thing that we have done in this part. Let me copy it. We want to create a sprite and append it to self.sprites. Or to be a bit more specific, BG sprites, they should always be in the background. The difference now is that the texture should be generated inside of Raylib, for which, number one, we have to create an image, which you can generate via gen image with a color, for which we need a width, a height, and a color. The width is going to be a random integer between 2 and 8. The height is always going to be 2, and the color is going to be the main color from settings. This value here. This is going to create an image, and that, to use it inside of a sprite, we have to convert to a texture. Which means I want to have a texture and then load texture from image, for which we want to use the image that we have just created. And now we have dynamically generated a texture that we can use in here, texture. And since the timer is working, this should be visible. Now we can see we get a couple of random lines, which in the right position would look pretty good. We just have to add a bit of an offset to the floor line. I went with 160, and for the random values, I went between -10 and 30. And now we get a much more 3D-y feeling thing. And you can see in the bottom, we are loading a whole bunch of stuff. If you look at the documentation, you can create quite a few different kinds of images. If you need something more random, this can be incredibly powerful. But anyway, this part has gotten quite long, so let's finish it here. To finish the main part of the game, we have to add a score and collisions. For the score, there should be one class that does all of the work. And for the collisions, we want to do that via circles, so it is a bit more forgiving. Let's start with the score, which we can create inside of sprites. So in here, I want to have another Python file. Let me place it all the way at the bottom. Class score. This one is not going to need the inheritance, but we do need a dunder init method with self and then the font that we want to use. This should be an attribute. Self.font is going to be font. So far, so good. We now have a class that can store font. To actually make this thing do something, we want to have a draw method with self and the score that we want to display. Fundamentally in here, we want to get draw text x like we have done before. We already have a font, so self.font. Then we need the actual text. Let's for now just say score 1, 2, and 3. After that, we need a position. The score should be in the center top, which we're going to do in a second. Let's for now simply place it via a vector 2 at 640 and 100. Then we need a font size. For now, let's go with 50. Spacing is basically always 1. And for the color, I want to have the main color, the one that we are getting from the settings. Still this one here. Once we have that, inside of dino.py, I want to import score. First of all, we have to create one instance of it. Let's do it right below the Dino. Self.score is going to be one instance of the score class. This is going to need one argument, which is the font that we first of all have to import. It's inside of the fonts folder, and all of this should happen inside of import assets. I suppose we can put it inside of self.assets. I want to have the font, which we get via load underscore font. With the join method, I want to go to fonts and the file is called retro underscore space dot ttf. This we want to use in here, self.assets and the font. Then we have the score, and on this thing, we want to call the draw method, which should happen inside of the draw method of the class, somewhere at the end. I suppose this thing should be on top of all the other stuff, so self.score.draw. With the score, for now, let's go with 1, 2, and 3. Once we have that, we get a score that we have to refine in a couple of ways. Number one, it should actually do something, which we can do quite easily. We just have to use this score information. I want to create a score text, which is going to be, I guess we can use an F string once again, where we have the score and then the score information from the parameter. This in turn we can use down here. And then back inside of the draw method, this number should now be displayed. So if I change it to, let's say, 100, then we should be getting 100, and we do. Looks good. To get the elapsed time, I want to get time. Let's see how that is looking. And that is pretty okay, although we do want to have an integer, which we could update here, or we could do it inside of the F string. I'm going to go with that, like so. With that, we should be having the proper text, and that is much better. Besides that, I want to get the position of this text, and remember, we are always placing the top left. So we have to add some kind of offset to the x value to get the entire thing centered, which we have done before as well. In my case, I want to get the text underscore width by using measure text x with self.font, the score text. The font size is going to be 50, spacing is going to be 1, and then we are done. This thing is now going to return the size of the text. So we get x and y as a vector, x being the width and y being the height. Since we only care about the width, we can add .x and we get the text width. Once we have that, we can do 640 minus the text width divided by 2. And with that, the text should be centered. That looks pretty good. With that, we are nearly done. There's just one minor thing, and that is that the text doesn't look very good. It might be hard to see, but the entire thing is a bit blurry, which happens because when we import the font, it has a default size. And when we then scale it up via the font size here and here, it is being scaled up in the code, which tends to look pretty bad once you get to a certain size. And that we can fix by using load font underscore x. In there, number one, you still have to specify the file name. But besides that, we also have a font size. If I set this to 50, the same number we have used in here and here, the entire thing is going to look a lot better. But before we can get to that, we have to add an argument for code points and code points count. Simply add none and 0 in here, and you should be good to go. Now, the text is going to look a lot better. And at this point, we have used this 50 quite a few times, so this should be a constant. Inside of settings, I want to have a text size, or rather font size, that would be more accurate. Let's go with 60 to make it a bit larger, and then inside of the sprites, this 50 and this 50 should be the font size, and inside of Dino, when we import the font, this should also be font size. The rest should still work just fine, and that is working really well. Cool. And while we are here, one more thing that I do want to do is that this number should be relative to the window width, meaning I want to have the window width divided by 2 minus text width also divided by 2. I suppose we could put all of this over multiple lines, something like this. Cool. With that, we have the score. Next up, to finish the main part of the game, I want to have collisions, for which I want to have one more method. Let's place it here. Define collision underscore check. Basically, in here, I want to get all of the obstacles and then check them against the player using circle collisions. For that, we will need a couple of things. Most importantly, number one, we need to have access to all of these obstacles. The easiest way I think to achieve that is inside of Thunder init. I want to have one more list, self.collision underscore sprites. Any sprite that is inside of this list will be checked for collisions with the dinosaur. And we only want to get these obstacles, which means I want to append them to the sprites so they get updated and drawn. And I want to get self.collision_sprites.append sprite. Then we can check for collisions. For sprite in self.collision sprites. And then I want to get a player circle and obstacle underscore circle. Both of these should be a list where we get the center and then the radius. This should apply both to the player and to the obstacle circle. Once we have both of those, we can do a very simple collision check. Check underscore collision underscore circles, for which we need the center and the radius for the player and the center and the radius for the obstacle. We can print game over and we can exit the game, which means all we have to figure out now is how to get the player circle and the obstacle circle. This part will be your exercise. I want you to get the player and the obstacle circle, for which you want to get the center and the radius. And just to be super clear here, if this is the texture for either of them, the center would be this point and the radius would be this value here. These are the two things that you want to get. All of this should happen inside of the class. Pause the video now and see how far you get. Inside of sprites.py, we want to get something for the moving sprite and for the dino. Since both inherit from sprite, we can work in here. And then create a method, define get collision circle. What we want to do in here is to return a list with the center and the radius. The center is going to be a vector2, in which we get self.pos.x and self.pos.y. Although this, we have to refine quite a bit. If this is the texture, then the current position would be the top left, but we want to get the center, which isn't difficult to get, and let me work over multiple lines. To x, we want to add self.texture.width and divided by 2. For the y position, we want to get self.texture.height and also divided by 2. This would bring us closer, but there's one important thing we haven't covered yet. And that is for all of the drawing, we are scaling things up by a certain factor. And this we have to include in here as well. In my case, I simply multiplied the width and the height of the texture with this scale. And then we should be getting the center. Next up, for the radius, you could pick one of these two values. Since the height is a bit more important for jumping purposes, I want to get this one, and then we have the radius. That's pretty much it. Back inside of dino.py, the player circle is going to be self.dino get collision circle. For the obstacle circle, we want to get the sprite that we get from the for loop, and then call the same method, get collision underscore circle. Since that method is inside of the parent sprite class, it should be available for the moving sprite and the dinosaur. After we have that, inside of check collision circles, we want to get player circle 0, so the center, and then for the radius, player circle 1. After that, obstacle circle 0, and obstacle circle 1, the center, and the radius. And after we have all of that, we should be having collisions. We just have to call this method, which happens inside of the update method after we're doing all of the other stuff, self.collisionCheck. Make sure to call it, and then in the game, if we run into a cactus, the game should be over. And there we go, game over. So with that, we have a functioning game. To finish the game, we have to add a couple of minor bits. Number 1, we need background music. Number 2, there's one enemy that should be animated, but fundamentally, this is just another obstacle. And finally, we have to delete obstacles that aren't needed anymore. I'll explain this one in a second. First of all, though, I want to work on the music, which we have to import from audio, and there we have music.mp3. For that, inside of import assets, I want to have inside of audio a music key. Remember, for this one, we have to load a music stream. After that, we need the file path via the join method. We want to go to audio and then to music.mp3. After that, inside of the init method, somewhere in there after import assets, we have to start the music. I suppose we can move all of this down a tiny bit and then play music stream with self.audio and the music. This function has to be called after import assets. Also really important, remember from what we did in the basic game, inside of the update method, you have to update the music stream, which is very simple. Update underscore music stream with the file that you want to update, which in this case is going to be self.audio and music. With that, we should be having background music. This works really well. With that, we have music. From this point going forward, I am going to stop recording the background music. It's still going to be there, you just can't hear it. That way, it's going to be much easier to hear me talk while the game is running. Next up then, when you look at the asset folder, there, besides the cacti, we have an enemy. This is a flying dinosaur. This one we want to import and animate, but other than that, it's just going to be an obstacle, which means we have to expand the moving sprite class to account for animations. On top of that, inside of dino.py, when we spawn an obstacle, we have to get a bit more randomness in here to either spawn a cactus or a flying enemy. You know the drill by now. This is going to be your exercise. I want you to expand the moving sprite class to include enemy animations. To make all of that work, import the enemy images and randomly get either them or a cactus. Pause the video now and see how far you get. Number 1, we have to import the enemy PNG files, which is going to happen inside of import assets. In here, let's do it below the clouds. I fundamentally want to do what we have done before. Let's call it enemy, for which we want to go to assets. There we have enemy, and the file name is called enemy 0 and 1. So we want to go from 0 up to 2, but not included. That should give us the enemy file. That covers the import. So next up, we have to figure out inside of the moving sprite how to work with multiple textures. So either for the texture, we can have a single cactus or a list of textures for the enemy. And the way I approach that, instead of a single texture for the parameter, I want to have textures. And then, when we initialize the parent class, I want to pick the first item from it. For that to work so far, inside of Dino, when we spawn the obstacle, in here, when we pick one of the cacti, we have to add a list instead of a single texture. If there's only a single item in there, then the functionality here is not going to be changed. Although for that to work, we have to do the same thing for all of them. This should always be a list. So spawn cloud, spawn floor should also have a list. And finally, inside of spawn floor lines, this texture needs to be in the list as well. With that, I can run the whole thing, and so far, nothing has changed. There we go, we get a cactus, and we should also get a cloud, and we do. This looks good. But what we can now do inside of spawn obstacle, we can decide if we get a cactus or the enemy animation, for which I want to add a bit of stuff before we create the sprite. And in here, I want to get the textures. This can either be what we have done before, so all of this, and this should be the default choice. So let's say 70% of the time, we want to get the cactus, but the other 30% of the time, we want to get the flying dinosaur. The easiest way of achieving that is using a ternary operator, and we want to get a random value between 0 and 10. If that value is below 7, then we want to get a cactus. And I guess this should be smaller than or equal to 7, but you get the idea. If that is not the case, else, then we want to get self.assets, and I think I called this one the enemy. The list that we have just imported, this one here. Since this already is a list, we can keep it as it is. In either case, we would get a list of textures. And this we want to pass into the moving sprite. Textures. And just for now, I want to reduce this number to a 3, so we get a lot more flying enemies. For testing purposes, this is going to be much better. And now we should be getting flying enemies, and this looks pretty good. We also get cacti. This part works. Now we just have to figure out how to animate these flying dinosaurs. For which, back inside of moving sprite, we have to do kind of what we have done for the dinosaur. Basically this part here. Let me copy all of this and then work inside of the update method of moving sprite. In here. Number 1, to make all of this work, we will need a frame index. We can just add it, self.frameIndex is going to be 0. On top of that, we have to store the textures so we can reuse them. That's also pretty easy. Self.textures is going to be textures. And after that, we are increasing the frame index by the animation speed and delta time. We also make sure that the frame index doesn't exceed the textures, so this should be just self.textures. And finally, we have to update self.texture. Remember, this one is what we're getting from the parent class. This value here, this is what actually gets drawn. So self.texture is going to be self.textures with self.frameIndex. And I suppose all of this is only needed if the length of self.textures is greater than 1. This part technically isn't needed, because if we only have a single image inside of textures, we always get the same number in here. So this is always going to be 0. So add this if you like. I'm going to keep it. And now, inside of dino.py, we should be getting an animated dinosaur. And we don't, because inside of the sprites, when we get the frame index, we have to get an integer. Next attempt, we get a cactus. That's a bit unlucky. But now we get a dinosaur, and the collisions also still work. So this works really well. Perfect. I suppose inside of the sprites, you could reorganize things a tiny bit to have the frame index and the textures inside of the sprite class. Because at the moment, we have a frame index and textures both inside of moving sprite and the dinosaur. And that isn't really necessary. Change it if you like. I'm going to keep things as they are. With that, we have to do one more thing, and that is, at the moment, we are spawning a whole bunch of stuff. Meaning we add more and more elements inside of the game, but we never get rid of them. And to demonstrate the problem, inside of the run method, after we're doing everything else, I want to print the length of self.sprites. Sprites is where we basically have all of our sprites. So in here, we have basically all visible elements. Besides that, We have the BG sprites, which I also want to get. I suppose inside of the print statement, I want to add both of them together. So the length of self.bg sprites. Those two combined are basically everything visible inside of the game, and there's going to be a lot of it. If I just keep the game running for a couple of seconds, we already get 40, then 50, and eventually 100 elements, more and more elements, and we never get rid of them. And that is a problem because the game still has to manage all of these elements, even though they're not visible. For this kind of game, this wouldn't be an issue because it's very, very simple. But once you make anything slightly more complex, this kind of cleanup operation is really important. To account for that, I want to create a define remove sprites. Basically, what we want to do in here is to get rid of any kind of sprite that goes too far left. If they're not visible anymore, we can simply get rid of them. The way to achieve that is via simple list comprehension. I want to get sprite for sprite in self.sprites. With that, at the moment, we are simply copying the list. But what we can now do is to only keep an element if the sprite.position.x is not too far left, which I have set to being greater than minus 300. If an element is further left than that, we can safely get rid of it. It will never be visible again. The same thing, let me copy all of this. We want to do for the BG sprites. So BG sprites is going to be sprite for sprite in self.bg sprites if sprite.position.x is greater than negative 300. After that, inside of the update method, after we have done all the other stuff, we can self.remove sprites. And with that, we are still printing the amount of sprites we have inside of the game. If I now keep this running, I think the number should never go that much higher than maybe 50, actually 30. Now we can see we keep the elements at around 33 to 35. And this would keep the game much more performant, especially if it runs for longer. And with that, we have the basic project. All combined, this project took about, let's say, 200 lines of code. And it looks pretty nice. With the 2D stuff covered, we can work on the 3D game, for which, luckily, most things are not going to change. 3D is mostly going to work like 2D. We are still going to generate lots of frames per second and move things around. That being said, there are going to be two things that are going to change drastically. Number one, the coordinate system. We are now working with 3 coordinates, x, y, and z. X is left and right, y is up and down, and z is forward and backwards. And this time, the y-axis points in the right direction. Meaning if you want to go up, you have to increase y, which feels much better. Besides that, we are now working with models. That basically means that we are going to define points in a 3D space, and by connecting them, we can create a 3D object. For example, a cube would have a point here, one here, and here, and here, and then a few more in the back. And if we connect all of those, eventually we get a 3-dimensional object. Like so. These meshes are a lot more complex than images, and they're also much harder to load. So when you're working in 3D, the performance is much more important. You can run into bottlenecks really, really fast. On top of that, for animations, we can't just play images in sequence anymore. Instead, we are going to need skeletons. Via that, we are moving all of these points around to change the shape. Now to get started, here we are in VS Code, and I already have a very basic setup. We have a game class where we are initializing a window. We have an update and a draw method, neither does anything. And inside of run, we're getting delta time, and then we are calling update and draw. At the end of it, we are creating one instance of the game class and running the entire project. That way, at the very least, we're getting a window, but other than that, this doesn't do very much. On top of that, we have the custom timer that we have seen before, and we have settings in which we are doing the imports, and we have the screen dimension. Later on, I am going to add a bit more in here, but that doesn't matter so much. On top of that, we have a couple more folders. For the assets, then we have audio and the font. All of this should be reasonably straightforward, so don't worry too much about it. I'll talk about it when we need it. For now, I want to talk about how to create the most basic kind of 3D project inside of Raylib. There are a couple of things that you need. Number one, inside of the draw method, you need two drawing functions. You need begin drawing along with end drawing. Between these two lines, we are still going to draw the entire project. But by default, in here, you can only draw 2D objects. To create 3D ones, you need begin mode 3D, which also has an end mode 3D. And then between these two functions, you can create actual 3D stuff. For example, you can draw a cube right away, for which we need a position, and this is a vector 3. Vector 3, where we have x, y, and z. As I've said before, x is left and right, y is up and down, and z is backwards and forwards. Although for now, I want to stick in the origin point, so 0, 0, and 0. Then we need 3 floats with the dimension. And for now, I want to have a width of 2, a height of 1, and a length of, let's say, 0.5. Finally, we are going to need a color. Let's go with red. And now, if I run the project, we get an error message that begin mode 3D needs one argument, and that is going to be a camera 3D. In 3D, you always need a camera, and this camera needs to have a couple of options set to work properly. And this we want to create inside of the init method. I want to create self.camera, and this has to be a camera 3D. Make sure to call it, and then for begin mode 3D, self.camera. With that, I can run the project. It doesn't crash, but, well, we can't see anything. I suppose to make things a bit more visible, we can clear the background before mode 3D and give the entire thing, at the very least, a ray white color. Should make it a bit more understandable. There we go. Now we have a white background. So how come we can't see this cube? And, well, for that to work, this camera needs to have a couple of options specified. Quite a few, actually. Let me go through them one by one. To get started, the camera needs a position, which is going to be a vector 3, once again, with x, y, and z. For now, let's go with 2, 0, and 1. 2 for x, 0 for y, and 1 for z. After that, the camera is going to need a target, also a vector 3. This is going to determine where the camera is looking. And since we want to see this cube in position 0, 0, and 0, this is going to be our target. After that, we have to tell the camera where up is, so it knows how to orient itself. In our case, vector 3, 0, 1, and 0. The y-axis typically is up. This one very rarely changes. We are about halfway done. Next up, we want to have self.camera field of view y. The field of view is determining how much the camera can see. I am setting this to 45 degrees. And finally, we will need a self.camera.projection. This one is a bit more technical. It basically determines how the 3D thing that we are watching, at the moment the cube, is translated into 2D. This one you usually don't want to touch and simply rely on the default value, which we're getting from Raylib, so RL, and then we have the camera perspective. And now, if we run the project, we should be seeing a cube. And we do. There we go. I guess if I make the cube a bit smaller, let's go with 1, 1, and 1 for all dimensions. You can see it a bit better. There we go. Now we have a cube. I'll talk about this in more detail in just a second, But for now, the really important thing that you have to understand is that when we are working in 3D, there are two major things that we need to get started. Number one, a camera with all of these options. And number two, begin mode 3D with the camera along with end mode 3D as well. Once you have both of those, you can draw 3D objects. Those can either be generated right away, or you could create a couple of models and then draw those, which is usually what you want to do. Let me actually do an example. I want to have test objects. And for that, we will need two things. Number one, we need a mesh. And number two, we need a model. The mesh determines the shape that we want to create. So in here, we are creating points in a 3D space. Let me actually create a self.mesh. This we can create via generate mesh, and then you get a whole bunch of options. I'm going to start with a cylinder. That tends to be a pretty easy one. For that, we need a radius, a height, and the amount of slices. For the radius, I want to go with 1. For the height, let's say 2. And for the slices, I want to go with 12. I will explain slices in just a second. But first of all, this mesh we cannot display right away. This mesh you could be drawing right away, but you probably don't want to. Instead, you want to create a model, self.model, via load model from mesh, for which we need self.mesh. Inside of a model, you basically have two things. Number one is the mesh, so you get the shape, and number two is a texture. That is going to give a color to the entire thing. Once you have both, you get a nice looking model, at least in theory. And to draw all of that, I don't want to draw cube anymore. Instead, I want to draw a model, which we can do in a couple of different ways. For now, draw model. We need a model, self.model. The position, once again, I want to have a vector 3 with 0, 0, and 0. Then we need a scale, 1, and a color. Let's go with red once again. We get a thing. I think we have to zoom out the camera a good bit. Let's change the x value to 4 and the y1 to a 1. Then you can see the cylinder a little bit better. Let's aim the camera a bit higher, 1. And there we go. Now we can see the cylinder. Alternatively, for a different angle, you can change the y position of the camera to a 5. That way, you can see the cylinder from the top. After that, to fully understand a 3D model, I want to change draw model to draw model wires, for which we still need a model, position, scale, and tint, all of which we have. So now, if I rerun this thing, you can see the points that determine this shape. Raylib created all of these points and connected them, and via that, we get a shape. And this process we can influence, because when we created the mesh, we defined three things: a radius and a height. I think those two are straightforward. And the slices determine how many points we are generating. If I set this to a 5 and rerun the entire thing, then we get a lot fewer points. Basically now, we are generating 5 points to create the outline shape. If I set this to 100, then we are going to get a ton of points around it. So effectively, the more points we have, the rounder this thing is going to be. You could also create other kinds of objects. If you go to Gen Mesh, and let's say I want to create a cone, there we need a radius, a height, and once again, we want to have slices. And for another example, I can create a cube, for which we need the width, the height, and the length. Let's set all of those to a 1, and then we are generating only a couple of points, because for a cube, the dimensions don't really matter. We only need the corner points, and then we get a cube. I guess for now, for demonstration purposes, I want to keep the cylinder. There we go. That looks all right. And I don't want to draw the wires so we can see it properly. There we go. Now, once again, we have a cylinder. But this cylinder shouldn't be pure red. I want to have a proper color. For that, we have to give this model a texture, which is just going to be a 2D image. This we could import or we can generate it right away. For example, we could create a gradient texture via gen image gradient linear. We want to have the width 256, a height 256, a direction. This can just be 0, doesn't really matter. And then we need a start and an end color. I want to go from sky blue to, let's say, dark blue. So we get a blue gradient. Via that, we have an image. And I should be clear here, we don't have a texture, we have an image. To get a texture, let's call it the texture. We have to convert the image via load texture from image, along with the gradient image we have just created. And once we have a texture, and this could have also been imported, we can assign it to the model, for which you want to get self.model.materials, and there can be multiple, but we want to pick the first one. On there, you can target the maps, and in here, we get a whole bunch of options. For 3D objects, you can assign a lot of different textures, but the most basic one is Raylib material map albedo. This is the basic color. On there, we have a texture, and to that, we want to assign the texture we have just created. Quite a bit of stuff, but once we have that, we are getting a different kind of thing. At the moment, that happens because we are multiplying this gradient with the red color from the model. If I change this to white, then we only see the material that we have created. So now we have a blue gradient. Although this thing does look a bit weird, and that should be expected. On the round thing, we do get a gradient. And let me make it a bit more visible. Instead of dark blue, I want to get red. Now we can see it a bit better. We are getting a gradient around the round bit, but not on the top or on the bottom. That happens because Raylib has to figure out how to assign a 2D texture to a 3D mesh. And if you don't have the right information to assign these two things together, the end result is always going to look a bit weird. Now, that unfortunately we cannot fix inside of the code. That's something you have to do when you're creating the art asset. I'll talk about this when we come to the importing part next. Just keep in mind, when you generate objects inside of the code, you're always going to be a bit restricted. We are nearly done with this part. To add an exercise, I want you to create a sphere with a gradient. Choose whatever color you want in here, it doesn't matter. On top of that, try to make it move in any direction. I haven't covered this part yet, so you do have to experiment a bit. I guess as long as you get any kind of movement, you are good to go for this part. Pause the video now and see how far you get. I guess we can reuse all of this stuff. And number one, I want to generate a mesh that is going to be a sphere. Gen mesh sphere, where we have a radius and the rings and slices. Just to demonstrate, if I have a radius of 2, and for the rings and slices, we can go with, let's go with 6 and 6 for now. This should be visible already. There we go. We have a sphere. And just to demonstrate what rings and slices do, I want to draw model wires. Here you can see we have all of the wires. And now, if I change this number to 100, then we get a lot more points in this direction. And if I change this back to 6 and set the other one to 100, then we get a lot of wires in the other direction. If you have lots of points for both, then you get a really, really round object. Once again, you are generating points dynamically, and Raylib wants to know how many points it should generate, basically for the X and the Y direction. But in our case, I want to draw the model itself so we can see the sphere. That looks vaguely alright, although the camera should point a bit further down. I guess we want to see the origin point. There we go. Now we can see a gradient, and you can see here, because we are assigning a texture, so a 2D image, to a sphere, at some point this looks really weird. That unfortunately isn't a thing we can't fix at the moment. But later on, when we import images, that part is going to be fixed automatically. I suppose one thing that we could be doing is to set the direction of the gradient to 90. That way, we are going left to right, and this should look a lot better. There we go. This is a bit nicer. Now we want to move this thing, for which we are basically just drawing it in a different position. Remember, this vector 3 is setting a position. So if I change the x part to a 1, then we are changing the position. Although this is slightly hard to see, what we can do here is to draw a grid as well. Where we have slices and spacing, I want to go with 10 and 1. That way, we can see a tiny bit better what's going on, although I think the camera should zoom out. Or at the very least, we can make the ball smaller. That's a bit better. Now we can see the origin point is this point here. And we move the ball down this direction. So now the center of the sphere is here. And since the camera is further down in the x direction, the ball has come closer to the camera. I suppose a slightly better movement would be to have this a 0 and this a 1. That way, we are going to the side. That's a bit more visible. And if you want to animate this, all you have to do is to create a self.pos, which by default is going to be 0. And inside of update, self.pos plus equal, let's say 5 times delta time. And then down here, instead of a 1, I want to have self.pos. And now the sphere is moving in this direction. Cool, that's pretty much it. With that, you already have all of the really basic stuff that you need for a 3D game. Although for really good looking stuff, you want to import things. That's going to come next. To create an actually good looking 3D game, we have to import art assets. And for that, we have to talk about the different 3D file formats. Sadly, in 3D, there's no universal standard that everybody follows. Hence, you see different file formats that you should be aware of. One that you are seeing all the time is OBJ, or wavefront files. Those used to be the standard, but the format is incredibly old and very limited. It only holds geometry. There's no texture or animations, so you literally only get a mesh. You can still apply a texture to it and make it do stuff, but it's not exactly efficient. The modern format that you want to use the most is GLTF. This is the new standard that is pretty much becoming the default nowadays. It contains a mesh, a texture, and a skeleton. A super powerful format. And finally, we have GLB, which is basically GLTF. So we are still containing a mesh, a texture, and a skeleton. The difference between these two is that GLB files are all condensed into a single file that you cannot edit anymore, whereas GLTF is still editable. Especially when you want to change things, this is super useful. But let's have a look in practice. Back inside of VS Code, at the moment, we have a sphere that's moving away. This I don't want anymore. So let me comment out all of this. You could also delete it. We don't need it anymore. While we're here, the position update should also be commented out. In fact, let me get rid of all of this. We really don't need it anymore. I still want to draw the grid. I guess this one can stay. But other than that, I basically want to have this, an empty area. And then import actual files that we want to display, for which inside of assets and test assets, we have the file formats that I just talked about, along with a couple of other things. Let's go through them step by step. The ideal file type that you have is a GLB file, this one here. This is by far the easiest one to work with. You simply import it, and then you have a model that you can display. All you have to do is let's call it test GLB load model, where you are going to use the join method for the proper path. We want to go to assets, in which we have test underscore assets. And in there, I want to get rupee.glb, rupee underscore red to be specific. And with that, we have a GLB file that we can draw right away inside of Mode 3D. So in here, we want to draw a model. The model is going to be self.testglb. Position is a vector 3 with 0, 0, and 0. The scale is going to be 1, and tint color can be white. With that, we should be having a rupee, and we do. This one looks pretty good. If I move the camera a bit further down the z-axis, let's change this to a 3. We can see this a bit better. This works well. Besides that, we have self.testgltf, which we can import in just the same way. Let me copy this line. And then we also have rupee red gltf. And if I open this file, you can see that we can read the content here. Lots of information that we don't really care about, but still, you could change it if you really wanted to. And this file, we can also just draw. Let me change test glb to gltf, and then we are getting the same rupee, except now in a different file format. So far, those are pretty much the same. However, if you look at test assets, there we have rupeered.bin. This file belongs to rupeered.gltf. This file contains the actual mesh that we are using inside of the gltf file. If you scroll down somewhere in there, you can see that it references rupeered.bin. Without this file, the gltf thing would not work, so we need both. It's a very easy thing to forget one of them, and then the project would crash. So do be careful here. Other than that, though, you are pretty much good to go. Next up, we have a sort.obj file. Let's create a new attribute, self.sort, and then, once again, I want to load a model. This one always works in the same way. Sort.obj. And this sort, I want to draw down here. And then we are getting a white sort that at the moment is very hard to see. Let me change the background to black. That way you can see at the very least we do have a sort. And I think if I change the position to x being 0 and y being, let's go with 1, there you can see we have a sort. But this sort is pure white, meaning we don't have a texture. That is because inside of sort.obj, we only have the mesh, nothing else. If we want to have colors, we have to import sort texture as well. This one looks like this. This we have to import manually and then apply it to the sort model. We have kind of done that before. I want to get a texture and then load a texture from a file path, not from an image like we have done in the last part. I want to get join and then copy what we have done before. I want to go to test asset, like so, and then import the sort underscore texture.png. This thing here. After we have that, I can get self.sort.materials 0, on which we have maps, and we want to get Raylib material map albedo.texture and assign the texture to it. That's the entire line. And with that, if I run the project, we are getting colors. And that covers the main file types. Now for this project, I am basically always going to use GLB files. If you look at the folders, you can see we basically always have GLB. That being said, we are not quite done yet. There's one more thing that we have to cover. And that is, if you look at test assets, we have one more GLB file, offset create.glb. Let me import this one. Self.rate. And then I want to load a GLB model. Let me copy all of this. This one is called offset underscore create.glb. If I draw this file down here inside of draw model, and remember our position is 0, 0, and 0. But inside of the project, this create is offset. To understand why that is happening, we have to look at Blender. Here we are in Blender. This is a 3D editing software. All of the assets you see inside of the game were created in Blender. The crate that we want to import is here. And you can see that inside of this coordinate system, we have an origin point here and then the crate a bit offset from that point. That position is stored inside of the GLB file. Or in other words, when we are loading the crate, we are loading the entire coordinate system with the crate in one specific place, which means when we are showing it inside of the game, we are keeping the same offset, which, if you don't know about it, is really, really frustrating. Just always keep it in mind. If a file is offset inside of Blender, it will be shown inside of the game that way as well. I want to overwrite the offset crate and then export GLTF like so. And if I now return to VS Code, now we have the crate in the center of the coordinate system. If you ever can't see an object that you imported, this might be the reason. It might just be offset by a massive amount. And with that, let's do an exercise. I want you to create a jumping player, for which you want to import a player object and display it via a class. Ideally, also create a base object so we can reuse some logic for the obstacles later on. On top of that, add a jump mechanic. Whenever the player presses space, the object for the player should be jumping. Pause the video now and see how far you get. Back inside of VS Code, I want to, inside of code, create objects.py, in which from settings, import everything. And then I want to create a base class object, for which we need a define dunder init with self, the model we want to show, the position, the scale, and finally the groups. After which I want to do the usual stuff. All of the parameters should be attributes, so self.model, position, scale, and groups is going to be model, position, scale, and groups. That way, we are storing everything. On top of that, I want to assign the object to a group, which we're doing here. After that, to display the model, I want to have a draw method in which we are calling draw model with self.model, self.position, self.scale, and the tint color is always going to be white. That's pretty much all we need in here. After we have that, class layer, which is going to be a child of the object class. To make that work, we will need a dunder init method in which we get the model, the position. We don't need a scale. That one is always going to be 1. Then we want to have the groups. And that's all we need for now. After that, super dunder init, where we pass through the model, the position, scale is going to be 1, and groups is going to be groups. With that, we should be able to display the player model, for which inside of Runner 3D, I want to have from objects import player. And then we want to create one instance of it, for which number 1, we will need the groups. Self.groups is going to be a dictionary where we have all, which is an empty list. And then finally, self.player is going to be the player class, and we need a model, for which I, for now, want to load a model from the player folder. We can basically copy all of this and make some changes. I want to go to assets. There we have the player folder, and in there we have player.glb. Next up, we have a position, which can be vector 3, 0, 0, and 0. The player is going to be in the origin point. And then self.groups and all. Really important, these groups should be inside of another list. That way, inside of this for loop, we're getting the groups, not the content of the groups. Super important difference. Once we have that, all we have to do inside of the draw part for object in self.groups and all object.draw. Let's see. And there we go. We have the player model. Not exactly perfect for the camera. This one should have a position of 10, 5, and 5. And the target is going to be 0, 1, and 0. Next attempt. And that is looking significantly better. Now we have the player model, and we are displaying all of this via some classes. Next up, I want to add the jump mechanic, for which we number one need an update mechanic with self and delta time. Although inside of the parent class, this is not going to do anything, as in here. The same thing I want to do inside of the child class, self and delta time. Although in here, we do want to do something. I want to, number one, check if is key rest with Raylib and key underscore space. If that is the case, I want to, for now, print jump. Then we have to call the update method, which inside of the main game class is going to be basically another for loop. Let me copy all of this and then call update with delta time. Inside of the game, I can press space and we get jump. Looks good. And basically now, when we are initializing the player class, I want to add a bit of stuff for the jump. Number one, I want to have gravity, which is going to be 5, then self dot velocity underscore y. This by default is going to be 0. And finally, self dot pos y, which is also going to be 0. And basically, inside of the update method for the player, I number one want to have gravity, which is going to be self dot velocity y minus equal self dot gravity multiplied with delta time. And this value we are then going to apply to the position of the player. The y position to be specific, so I want to have self dot y position, and this I want to add to self dot velocity y, also multiplied with delta time. And finally, once we have all of that, self dot position dot y is going to be self dot y position. With that system, number one, we get a velocity for the player. Then via the velocity, we are updating the y position. And then this is finally properly updating the y position of the player that we can see inside of the game. And this is also going to work much better if I name it properly. This is pos y. With that, if I run the game, we should have gravity. And the player is falling down. Looks good. All we have to do now for the jump is to make this velocity positive. Which means if key space is pressed, self dot velocity y should be some kind of positive value. Let's go with 6. And then, inside of the game, I can press space and we are jumping. Nearly done, we just need a couple of minor refinements. The most important one is that the floor should be a hard limit, so we cannot exceed it. To enforce that, I want to check if self.pos y is smaller than 0, and if that is the case, self.pos y should be 0, and self.velocity y should also be 0. That way, before we get to this part, we are stopping the player. The player isn't falling anymore, but if I jump, we still have gravity. Cool, this works. Next up, we can double jump, which for a runner style game is pretty much breaking the entire thing, so we have to adjust some minor parts. When we are checking for key space, I want to add a second condition, and self.position.y is smaller than or at least equal to 0. That way, we can only jump if the player presses space and the player is on the floor. If I do all of this, I cannot double jump anymore. But once I'm on the floor, I can jump again. And all right, with that, we have made a ton of progress. We can work with a ton of different files and we can create classes to organize our game. Now, going forward, I don't need all of these test files anymore. So let me get rid of them. Besides that, I want to have a define import assets. Like we've seen before, I want to create a self.assets dictionary in which we, for now, have the player, which we have imported here. That way, in the beginning of the dunder init method, I can import all of the assets and then use self.assets and player right here. The end result should be the same. Cool. This looks good. With that, we have organized our code just a tiny bit better. The next major part that we have to look at is going to be collisions. Those, like in 2D, are a vital part of pretty much any game. And luckily, in 3D for collisions, we are still going to apply the same logic that we have learned in 2D. The only major difference now is that a circle becomes a sphere for the collision and a rectangle becomes a bounding box. Once we have either of those two, we can call basic collision methods. And if you look at the documentation, you can scroll down quite a bit. At some point, you are going to find the models module. And in there, all the way at the bottom, we have three collision methods: collision spheres, collision boxes, and collision box sphere. For those, you either need a center and a radius, so you get a sphere, or you need a bounding box, which you have to create manually. And to implement all of that inside of VS Code, I want to import one obstacle and then check for a collision with the player. I'm going to go with obstacle 0, but import whatever you want. It really doesn't matter. Inside of self.assets, I want to have an obstacle, which we still want to import via load model. I want to go to assets, obstacles, and then get obstacle 0, for which we want to create a separate class. Inside of objects, let's do it above the player, class obstacle, where the parent is going to be an object. And for this one, I don't want to have too much. I basically want to have a dunder init method in which we get self, the model, a position. We don't need a scale or a speed. We just want groups. After that, inside of super dunder init, I want to pass through the model, the position, and like for the player, the scale is always going to be 1. For the groups, I want to have the groups. And then finally, we will need a self.speed, for which I want to have inside of settings a constant value. I'm going to call it the main speed. 4.5 is what I have chosen, just felt right. And this I want to use here. After we have that, define, update with self and delta time. And fundamentally, all I want to do is self.position.x plus equal self.speed times delta time. And with that, we should have at the very least something. Let me save the entire thing and then create a self.obstacle, for which we want the obstacle class that we, number one, have to import obstacle up here. And then we need, let me copy the stuff from the player. Gonna make my life a bit easier. All of this, except now instead of the player, we want to have the obstacle, and the rest can remain the same. If I now run the project, we get a chest and it's moving, but it's moving in the wrong direction. Basically, what I want for the obstacle is to have a start position at Z position 10. That at the moment is not going to make it visible. Yeah, we can't see it whatsoever. But if I change this to a 1, you can see at the very least the axis that we are moving in. This is 1. This is 3. We are going further and further down ahead of the player. And if we are at 10, we are outside the view of the player. So we cannot see when the object is being created, which is ideal. After that, instead of update, this shouldn't be position.x, it should be position.z. And now, if I run the project, we can't see anything because the chest has to go in the opposite direction. I want to multiply this with -1. That way, we get the chest, and this looks pretty good. Cool. With that, we have two objects that are going to collide, which means we can run a collision check. And for that, inside of object, I want to add two more methods. The first one is the one you probably are going to use the most. I want to get a BB, a bounding box, for which number one, I want to get a base bounding box, which we can get via the method getModelBoundingBox, along with self.model. This we could return right away. Base BB, and then inside of runner3D, for every object, we want to draw the object and we want to draw the bounding box. Draw bounding box with object and get BB. Make sure to call this one. And for the color, we can go with red, whatever you prefer. And then for the player, we are getting something, but for the chest, we don't. What's happening here? And well, if you look closely, in the center of the project, we get two bounding boxes. One fits the player really well, and the other would fit the chest really well. Because, well, it is for the chest. When we are running get model bounding box, we do get the right size bounding box. But this bounding box does not have a position. That you have to add manually. The way you want to think about it, let's say we get a bounding box that looks vaguely like this, where we have a cube like this, which is what we're getting from get model bounding box. This we now have to adjust for the position. And for that, we can get the center position. This is ideally the position of the model inside of the class. And then from that, we want to get the two corner positions. Since we have a cube, get the size, we just need this point and this point. So effectively, from the origin point, we want to get half the width of the thing, half the height, and half the depth. Once we have these and the center, we can go to this point and this point, and that we can use to create a new bounding box along a position. It is a bit tedious, but if you've done it once, it's pretty straightforward. I want to get, number one, half the width, half the height, and half the depth of the bounding box that we have gotten so far. And this should also work with the scale of the model. That's pretty important. Basically, what we have to do is to get the base bounding box, and there we have a max and a minimum value. I want to get max.x and subtract base BB min.x. That way, we get the width of the entire thing. And this we want to multiply with self.scale. And then finally, all of this, we want to divide by 2. With that, we get half of the width of the model. And this I want to do 2 more times here and here. For the height, I want to get the y value, and for the depth, I want to get the z value. This we can use to create a minimum point and a maximum point. These would be the two corners of the cube that determine the size, which we can then use to create a new bounding box, which wants to have a minimum value and a maximum value. So in my case, I want to have a minimum point and a maximum point. The minimum point is going to be a vector 3, where we want to have self.position.x minus half the width. This I can duplicate twice, because next up we want to get y and z, and then subtract the height and the depth. With that, we have the minimum point. Back inside of the cube, this minimum point is now this top left point here, which is going to be half of the distance from the center. Basically this path here. Next up, we want to have the maximum point, the one down here, for which, once again, we want to get the center point, move to the right, down, and then move down the x-axis. Once we have these 2 points, we have the size of the bounding box adjusted for the position. And basically for that, we can copy all of this, paste it in here. The only change that we have to make is that this should be a plus instead of a minus. And with that, we have the proper bounding box. Quite a bit of logic, but I think fundamentally, it's not that difficult. I hope it makes sense. Let's run the project, and now we get almost the right bounding box. The only problem is that they are offset. Let me run it again. Both of those seem to be a bit too far down. And that is because when you open the chest inside of Blender, you can see that the chest, for example, is on top of the origin point. So when we import this GLB file into Raylib, the position that we are working with is this point here, which, if you rotate the thing around, is in the bottom of the model. The same is going to apply to the player. Pretty much all the models that we are going to import have the origin point at the bottom, which means when we are creating these positions, we have to add an offset to the Y part, which in this part is very easy. We just have to add a +1. With that, inside of the game, we get basically the perfect bounding boxes. This looks good. This +1 here works because most objects have a height of 2. And if we go +1, then we are going from the bottom of the model roughly to the middle. And with that, we have the actual center, which is all we needed. Now that we have that, we can add another method, define get collision. And then I want to get for obj in self dot groups, and I want to have a collision group, which does not exist yet. But inside of groups, we can add a second value, collision, which by default is going to be an empty list, but the object should be inside of it, which means we want to have all of the sprites and we want to have the collision sprites. That way, we can access all of the collision objects. And then I want to get check collision boxes, for which we need 2 bounding boxes, which we can get super easily. The first one is obj dot get bounding box. The second one is going to be self dot player and then get bounding box as well. Finally, we have to call this method. After we are calling the update method on all of the objects, I want to self dot get collision. And to actually see something, I want to add an if statement. This is going to return either true or false. And if we have a collision, I want to print collision. With that, I can run the project and we should be getting a collision. And we do. We get a collision. Perfect. This took a second, but fundamentally, all you have to do for 3D collision is to get a bounding box, adjust it for the position, and then run check collision boxes. Now that's the first kind of collision that we can work with. Besides that, I want to add a second method, which is going to be get sphere, in which we want to return a center and a radius, which can then be used inside of get collision to run check collision spheres. This one is going to need a center and a radius for the first object and a center and a radius for the second object, which is going to be what we're returning here for each of the 2 objects. This part is going to be your exercise. I want you to finish the getSphere method. Once you have that, use it for the collision and also to make the game more understandable, draw this sphere. And as a tip for this one, you still have to adjust the Y position because of the model. Don't forget that part. Other than that, pause the video now and see how far you get. Alrighty. The center should be a vector 3 and the radius should be some kind of floating point value. And just to get started, I want to return self.position, and for the radius, we can go with 2. That way, we have a baseline that we can see if we draw it. And let me comment this line out. For now, besides the drawing box, I also want to draw sphere wires, for which we need a center position and a radius, which we get from object, get sphere with 0, that's the position, and then 1 is going to be the radius. Then we need rings and slices, which can just be 10, and finally a color. Let's go with green. And now we are getting a couple of spheres. This works at the very least somewhat. But once again, we have to refine a couple of things. Number one, for the position, we will need the y offset. And then we also need a radius to get the proper sized sphere. Number one, I want to get, once again, the base bounding box, for which we need get model bounding box with self dot model. This we can use to calculate a position, which is going to be a vector 3, where x and y are already covered. Self.position.x is fine. Same with self.position.z. But for y, we have to make a change. And to be super precise here, we want to go up by half the height of the model, which we get from the model bounding box. We basically want to do what we have done up here to get half of the height, which I want to add in here as well. That way, we get the exact center of the model. Let's try that one already. Instead of the position, I want to get the center. Next attempt. And this is looking significantly nicer. After that, I want to get the radius. Let's call it radius. And let me draw the logic here. We have, from the base bounding box, some kind of cube that looks vaguely like this. On this box, we have a center, and now we have to determine the radius. We kind of have to make a choice. For the radius, do we want to get the width of the model and divide it by 2, the height of the model and divide it by 2, or the depth of the model and divide that by 2? Depending on the model, this can be really important. For our purposes, it really doesn't matter. So what I want to do is to get the largest of these values and then use that, for which we can get the max function, and then we need half of the size, pretty much what we have done up here. Let me copy it actually. I want to get these 3 values and then pick the largest one. This would then be the radius. Let's try. And there we go. This looks like a pretty good sphere that works well. After we have all of that, we can call check collision spheres, for which I guess number 1, we want to get the position and the radius, which we get from object get sphere. This part would be for the obstacle, and for the player, let's create a player pos and a player radius. And this we get from self dot player get sphere as well. With all of that, inside of check collision spheres, we need center 1, radius 1, center 2, and radius 2, which means position and radius, and then player position along with player radius. While we're doing that, let me comment out this part, add an if statement. And if this part is true, I have a sphere collision. Let's try. And now we get a sphere collision. This would be the second kind of collision in 3D. Once again, if you understand the basic math here, this is pretty straightforward. And also, before we finish, I think instead of adding a +1 here, we should just do this part. That way, we get much more exact values, which just feels better. Just to try, when we are creating the player and the obstacle, I want to change the scale to 2. Inside of the project, all of the collision spheres should still work and this looks really good. Cool. With that, we can create collision boxes and spheres that work with the scale of the model. And for the actual collision that I want to use inside of the project, I want to check if check collision box sphere. For the obstacles, I want to get the B box. Dot get bounding box. However, for the player, I want to get the player position along with the player radius. If that is the case, I want to, I guess for now, print with game. Then we don't need this line or these lines here. And we get a bounding box for the obstacles and a sphere for the player. Let's see if that still works. It should. And that looks good. We want to quit the game and also reset the scale to a 1. Here and here. Next attempt. Now the player gets a bit more of a forgiving collision shape that makes the game more fun. And what you can also do at this point for the getSphere method, we can multiply this radius with some kind of number to make it smaller. Let's say 0.5. If I now run the project, the player sphere has become much smaller. Depending on how difficult you want the whole thing to be, change this number. It's a very easy way to scale up the difficulty. I'm going to leave it at 0.5. Now that we have collisions, we can work on the obstacles, which we are going to spawn like in the 2D game, with a timer. In fact, this part can be an exercise right away. I want you to import the obstacle objects and then spawn them regularly using a timer. Pause the video now and see how you get. If you look at assets and obstacles, there we have 3. And all of those we want to import and then pick one of those randomly. Which means inside of assets, I want to have obstacles and then import multiple, which we can do via list comprehension. I want to do all of this, and the file name is going to be an F string, where the number is going to be, let's call it I. And then for I in range 3. That way, we are going from 0 up to 3, but we are not including it, meaning we get 0, 1, and 2, which is all we need. After we have that, when we are creating the obstacle, we want to get all of them and pick one of those randomly, which we can do via the choice function, which we have to import, which we can do inside of settings from random import choice. And then I can try all of this. We are getting a crate. Next up, we are getting a chest. And then let me try this a few more times. At some point, we are getting spikes, so this is working pretty well. Now that we have that part, I want to spawn these bits via a timer, which we already have at the top, timer. All we have to do is self.timers, and let's call this one obstacles. A very basic timer with some kind of duration. For now, let's go with 5 seconds. For the callback, I want to have self.create obstacle. This one should auto start and it should repeat. After that, we will need create obstacle. Let's place it down here. Define create obstacle without any custom parameters. And all I want to do in here is to basically create one of these objects. Let me copy it, paste it in here. We don't have to store it inside of an attribute. Simply creating it is enough because we have the groups to keep track of it. That means we don't need this bit anymore. And if we go down a bit, I guess we also don't have to draw these parts. They are getting a bit distracting. Let me get rid of them. That looks a lot cleaner. Inside of get collision, this part also works. And the run method is happy. Cool. The one additional thing that we have to do is to update the timer for timer in self.timers.values timer.update. With that, we should be having objects. We just have to wait a second. At some point, something should happen, and there we go. We're getting spikes. We are getting a chest. And at some point, we should be getting a crate. I think the timer is a bit too slow, but this definitely works. Cool. Just for testing purposes, let's set the timer to 1 second. That way, we can see a lot more objects. And this is looking pretty good. We are getting a ton of stuff. That works. While this is a good start, we are not done yet, because I also want to have the level itself. Or inside of assets, I call this one the floors. And we have two, floor 0 and floor 1. This effectively is the background. And this we want to import as well and kind of treat it like an obstacle, except the player is not going to collide with it. Let me demonstrate. Inside of the assets, I want to have floors. And for that, we need a comma here. I want to import the two floors like we have imported the obstacles. Let me copy all of this, paste it in here. We have two objects, so range 2. We want to go to assets, floors, and then import floor 0 and 1. Once we have that, inside of the dunder init method, so where we have created all of the basic stuff, I want to create an obstacle with self assets, the floor, and index number 0. So we get the first one. For the position, for now, we can do a vector 3 with 0, 0, and 0. For the groups, I want to copy what we have done in the player, like so. And then we should be seeing something. And we don't, because I have a typo. This should be floors. Next attempt. And now you can see we are getting a level, kind of. To see it better, I want to set the Z position to 15. And now you can see we are getting a much nicer looking level. Although at some point it disappears. And also it overlaps with the player, which isn't ideal. To fix that, I am setting the Y value to -1. Like so. That way, at the very least, it looks like the player is on top of the thing. Much better. Also at this point, we don't need the grid anymore. This thing can go. The name here might not be perfect because this object isn't an obstacle, but I think it works for this purpose. At the very least, inside of the game, we have a background. Now we just have to create more of those and make sure they are connected so that when one of these increments is over, we're getting another one right away. And the way I approach that is I have added another argument to the obstacle class. And in this case, it is called self.createBG object. This one doesn't exist yet. So we want to define create BG object with self. And then fundamentally, I want to do this, where we are creating another obstacle with a floor. Let me paste it in here. And then fundamentally, once we have one of these objects, we can create multiple over and over again. We just have to get the right start position to align them with each other. Although before we get to that, inside of objects, for the obstacle, we need one more parameter. We want to have a callback function where the default value is none. That way, all of the other stuff should still work. Let's try. And at the very least, the game isn't crashing. That's a good start. Once we have that, I basically want to check for every obstacle. If it has a callback function and crosses a certain position, then I want to call the function and create a new BG object, for which inside of the class, self.callbackFunction is going to be the callback. And then inside of update, I want to check if self.position.z is smaller than 14. So we are outside of the view of the player, and self.callback, meaning have we crossed a certain position and do we have the callback function? If that is the case, I want to call the callback function. This at the moment is going to crash the entire project but at the very least, it should work. And there you can see stuff is working, but it's working a bit too well. We are creating a ton of different background objects. Let me cancel this one. The reason is once the obstacle crosses this point, it keeps on creating new floors on every single frame, meaning we are creating a ridiculous amount of objects and the game simply cannot handle that. The way to fix that is to create another attribute, self.created, which by default is going to be false. And then we want to check self.created, simple typo, like so. We want to check if this value is false, so and not self-created, meaning this object at the moment hasn't called the self callback function yet. If it has, we want to set self.created to true. With that, we are only going to create a single one, at least ideally. And well, this is going a bit better, but still not ideal. The issue now is that our original object is in position, let me find it. Our original object is in position 15. And when we are creating another one, we are in the same position. And when we are crossing point 14, then we are creating a new one. So basically, every time we're crossing one unit on the z-axis, we are creating a new background object, which really isn't ideal. The distance here should be much larger. Let me set it to 80, then the entire thing should be working a lot better. And now we keep one floor, we have a gap, and there we have another one. The other stuff also works. So with that, we are making a ton of progress. There should be another one as well. Let me just wait a bit. There we go. This looks pretty all right. If you wanted to be super precise here, you could, when you're calling the callback function, pass in the size of the model for the obstacle and then adjust the position for that. Would be possible, but all of these objects have the same size, 74. If I now run the project, we basically have an infinite runner that is repeating and we don't get a gap between the different floors. And I think that is looking pretty alright. There's definitely nothing noticeable. Perfect. The one additional thing that we should be doing is to get a random floor like so. That should still work. Let's try. And this looks pretty alright. At the very least, nothing is crashing. That's all I'm looking for. So this seems okay. Perfect. That means at this point, we have a pretty good looking level. There are just some very minor changes that I want to add at this point. Number one, the background shouldn't be black. It should be sky blue. Because when we look through the windows up there, we want to have a sky. And I think sky blue, the default value here, looks pretty alright. After that, for the timer, I want to have 3 seconds, although this should be a constant. I suppose we can call it the spawn cooldown 3 seconds. And this I want to use in here. That way, the obstacles should be spaced out quite a bit more. There we have the first one. And the player has enough time to land. This works quite well. And to make this more organic, when we are calling create obstacle, let me find it really quick. Inside of create obstacle, besides creating an obstacle, I want to give the timer self.timers and obstacle is slightly random duration. Duration is going to be a random value. For that, I want to from random import choice and uniform. Uniform creates random floats. For the duration, I want to have a uniform value between A and B, for which I want to get the spawn cooldown minus 0.5 and the spawn cooldown plus 0.5. That is going to make the entire thing just a bit more random, and I think this was called obstacles. Yeah, the name here matches up. So now this should look a bit more chaotic, but I think in practice it's a bit difficult to see. But I think this still works just fine. With that, we have a much nicer level. By now, we basically have a working level, but it doesn't look as good yet because we don't have animations. This we're going to fix now by adding the player animations and some walking enemies. And I suppose we can work right away inside of VS Code. The first thing that we have to do is to import the skeletal animations, which are inside of the same model. It's a bit of a weird system, but basically what you have to do is you number one want to import the model, what we have already done, and then you want to call load model animations, for which we are literally using the same file path, all of this. We are importing the same thing, except now we are getting all of the animations. That being said, this function needs two things, the file name and the animation count, for which you have to specify a specific thing. We will need ffi dot new and then create an integer with an asterisk. After that, you want to add 0. With that system, we are creating an integer value that can be used by load model animation. Also, the 0 here can always be a 0. It does say animation count, but effectively, when Raylib is importing the model, it overwrites this number with the number of animations. For example, this model here has, I think, 50 different animations. Way more than 0, but the 0 here is still fine. Anyway, with that, we have the model animation. This we have to get into the player class here. I guess we are already getting the list in there, so we can work inside of the player class. The only thing that we have to do is to rename this to model data and then get model data with the index 0. That way, all of this should still work just fine. And it does. This looks good. And besides that, let me add another section in here for the animations. I want to get number one, self.animations, which we are storing inside of model data and 1. That is the model animation we have just imported. Inside of this animation file, we have a ton of animations. And I want to control which one we have via selected animation, which by default can be 0. After that, we are going to need a frame to know where we are inside of the animation. We are still working with a skeleton, but inside of the skeleton, we have individual frames that determine where stuff is moving at what point in time. So we're still having a frame attribute. And after we have that, we have to call the method update model animation, for which we need the model number one, self.model, then the animation. This is going to be self.animations. This contains multiple animations, and in here, we have to pick one, self.selected animation. And after that, we want to have the frame, self.frame. If I now run the entire thing, the model is going to look very slightly different. If you look at that, and I uncomment the line and run the project again, now the model is in the T-pose. But if we update the animation, so now the model is standing in a slightly different way. Definitely an improvement. All we have to do now is to create a define animate function with self and delta time. We want to get self.frame plus some kind of value. Let's for now go with 10 multiplied with delta time. And then we want to call update model animation once again with the exact same arguments. And if we now call self.animate with delta time, we should be getting an animation. Let's try. And we get a very, very slow one, but it does work. It is at the moment looping, but this works. Cool. The animation speed here is quite slow. For the actual project, I have set this to 30. That way, this is much better. There we go. We have a proper animation. that is looping by default, although I wouldn't count on that. To ensure that this is always happening, you want to add self.frame modulus equal self.animations with self.selected animation. And in there, we have the key frame count. You don't necessarily have to have this one, but I think having the control that we are definitely looping is a good idea. Anyway, now this should still working, and it does. Looks good. Basically now, we just have to get the right animation for running and for jumping. The running animation is number 54. If I play that, we are running. This looks pretty nice. And for jumping, it is 46. Doesn't look as nice, but once we're in the air, this works much better. By default, this value should be 0. And then, inside of the update method, when the player is jumping, we want self.selected animation and set it to 46. After that, when we are hitting the ground, it should be 54. That should be it. With that, we have a character animation that is making the game feel much, much nicer. Although I do want to change a couple of things in here. Number one, the animation speed should be a constant animation speed, which we have inside of settings, animation speed. 30 is a fine value in here. And I think having these values for the player also aren't ideal. For which I want to add another constant, player animations, a dictionary where we have run, which gets 54, and we have jump 46. After that, I want to get player animations with jump, and down here, I want to have the player animations with run. At this point, we can do an exercise and then we should be done. Besides the player, there are 2 running enemies that you can find inside of the file system. Import all of those and animate them. Once you have that, spawn either the enemy or an obstacle when the timer times out. This could be random. For both of these enemies, the running animation is also number 54. That should be all you need. Pause the video now and see how far you get. If you look at the file system, there we have enemies and a skeleton mage along with a skeleton warrior. Those we have to import. Inside of assets, I want to have one additional entry. I want to have the enemies in which we have a nested list where the first enemy is the skeleton mage, for which we have to load the model and the model animations. Let me copy all the stuff from the player just to save me some typing. Paste it in here. For the first enemy, we want to load model, go to assets, enemies, and in there we have skeleton underscore mage. Skeleton underscore mage. And this we want to use here, and we want to get the right folder. After we have that, I want to duplicate all of this and then load the skeleton warrior. That is all we need in here, and I do have a ton of white space now. That's a bit more readable. Effectively, we have for the player one list with the model and the model animations. For enemies, all of this is one list. And inside of that list, we have another list and another list. Each list contains the model and the animation for the skeleton. One is the skeleton mage, the other is the skeleton warrior. That data we now want to use, and for that, I want to create a new class enemy. Once again, we want to inherit from an object, which means we will need define dunder init with self. We want to have the model underscore data. We will need a position. And finally, I want to have the groups. Next up, as always, super dunder init, where we get model, data, and 0. The position is going to be passed through. Scale is always going to be a 1. And the groups are going to be the, well, groups. Once we have that, we basically want to do what we have done inside of the obstacle, meaning we want to have a speed and then move along that speed. Although that being said, what we can do to make all of this a bit more elegant is to inherit not from object, but from the obstacle. That way, we are already getting all of this anyway. The only change we have to make is that now we have these arguments for the parent class. So model data still works. We have the position, this one also works. But the scale we are already getting, that's a 1. We just need the groups. So with that, we have an enemy that does the same as the obstacles, which we should test. Inside of Runner 3D, when we are creating an obstacle, at the moment, we are always creating this obstacle. However, this I only want to do 50% of the time, which you could achieve in a number of ways. I think the easiest one is choice 0 and 1. If we get a 1, we want to do all of this, and else we want to create an enemy class or one instance of it, for which we have to import enemy. And then down here, I want to create, I guess we can copy the obstacle class and rename it to enemy. For the assets, we want to get self.assets and enemies, I believe I called it. We want to get all of this. Enemies, that works. The vector position is just fine. And we also want to have collisions for the enemy class, which is a good start. Let's see. Now we should be getting either an obstacle or an enemy. At the moment, we are a bit unlucky, but there we go. We have an enemy, and there should also be another one. This looks good. Cool. All we have to do now is to add some animation logic to the enemy, for which I want to store the animations, which we get from model underscore data and 1. We want to have self.selected animation, which is going to be 54. I suppose this could be a constant, and we can reuse the player animations and go for run. And finally, we need self.frame with a default value of 0. And then I want to call update model animation with self.model, self.animations with self.selected animation, and finally self.frame. Let's try this one now. And once again, we do have to wait a tiny bit, but at the very least, the skeletons should have a starting pose now. Getting a bit unlucky, getting even more unlucky. There should be a skeleton at some point. There we go. Now the skeleton looks like it's running, or at least we get one running frame. To get the proper animation, we want an update method with self and delta time. And on top of that, we want to make sure that we are still calling the parent update method, which means we need super update with delta time. I suppose in here, like for the player, we could create an animate method, but we don't really have to. All we need is self.frame plus equal animation speed multiplied with delta time. Then self.frame modulus equal self.animations selected animation and keyframe count. Once we have that, update model animation, basically what we have done up here. You can just copy it, paste it in here, and then we should be getting animations. Inside of the game, once again, we do have to wait a tiny bit, but at some point there should be a running skeleton. And there we go. This looks pretty good. That being said, I think you have already noticed the skeletons are facing in the wrong direction. That we can fix by overwriting the draw method. All we need is define draw without any custom parameters, and we want to use draw model x, in which we can set a rotation. Number one, we want to have the model. Number two, self.position. Then we need a rotation axis and a rotation angle, which in my case are vector 3, 0, 1, and 0. And the rotation angle is going to be 180 degrees. Basically, what we are doing here is in the three dimensions where we have x, y, and z, we number one specify around which axis we want to rotate. If you set this to 1, then we are simply going up. And if you then specify 180 degrees, we are rotating around this axis by 180 degrees. After that, we need one more vector 3 and the tint color. The vector 3 determines the scale, which means vector 3 self.scale 3 times. And finally, the tint color is always going to be white. That way, the skeletons should be facing the right way. Let's try now. And after a couple of seconds, we should be getting a skeleton. Let's see how lucky I get. And yeah, that looks pretty all right. Although, one additional thing that we should be doing is for the speed, the one we are setting here. We want to increase that value by a tiny amount, so it doesn't look like the enemies are static. For which, all we have to do is inside of enemy self.speed does equal some very small amount. Uniform between 0.5 and 1. That way, the game is going to look quite a bit better. Demonstrate. If we now get a skeleton after a couple of seconds, let's hope I get lucky. There, it looks like they are actually running, although I think we could increase the speed even more. Let's do between 1 and 1.5. Next attempt. Yeah, we have a skeleton, and this, I think, looks a good bit nicer. But once again, customize things to create the game that you would like to see. But anyway, with that, we have the enemies, which are just a really fancy obstacle. We are nearly done with the project. There are just a couple of minor things that we have to add. Most importantly, we need a score. Besides that, we have to make sure that we are getting rid of objects that are not needed anymore. Without that, the game is going to become very slow, very fast. And finally, we have to add sound. That should be pretty simple. Let's start with the most important part. And to demonstrate, I want to, inside of the run method, print the length of self.groups and all. This is going to contain all of the objects. And after a little bit, you're going to see that this number keeps on increasing and it never goes down. It just goes up. And we have a whole bunch of pretty heavy objects, which we never get rid of. And that's a problem. Every single object inside of this group takes up a little bit of processing time, which isn't good. So we want to get rid of objects once they get out of view. And that we can do inside of the obstacle class, because those are the only objects that are going to disappear. All we have to do in here is if self.position.z is smaller than minus 30. If that is the case, I want to destroy this object, which we can achieve by removing it from all of the groups, which is a very simple for loop. For group in self.groups, group.remove self. Since we are calling this update method inside of the enemy, they are getting that logic for free via this line. Which means, let me print the length of the entire thing again. self.groups and all. And now the length of this list is never going to exceed maybe 5 or 6. Let me run it for a bit. You are going to see how this is going to look if I play for a few seconds. There you can already see it. The amount of objects we have inside of the game is maybe 6 at some point, but for the most part, we have about 5 objects. Hence, the game is going to run significantly better. After that, I want to have a score, which I want to keep inside of a separate Python file, score.i, in which from settings import everything. And this class is going to be pretty simple. Class score define dunder init with self, and we need a font. Inside of this class, I want to get the elapsed time and display it and have a rounded rectangle around it. Here's the end result. This is going to be an exercise. I want you to create a score class. And to draw rounded rectangles, you can use draw rectangle rounded. There's also draw rectangle rounded lines. Just check the documentation and see what you need. Here are the colors that you need. Pause the video now and see how you get. We are going to need a whole bunch of attributes. A score, a font, which we get from the parameter. I want to add a bit of padding, 10 pixels. And finally, I want to have the center X position, which is the screen width minus 100 pixels. After that, self.top Y is going to be screen height minus 50 pixels. We can adjust these numbers later on. For now, I just want to have something. After that, via the update method, which doesn't need delta time, I simply want to get self.score is equal the string of the integer of get time. Integer, so it looks nicer, and string, so we can display it right away. Which also means the score should be a string when we are starting. Finally, I want to have a draw method in which fundamentally we want to get draw text x with self.font, self.score. The position is going to be a vector 2 with self.centerx and self.top y. We're going to adjust this in a second. The font size is going to be 40. Spacing is going to be a 1. And for the color, I want black. That should at the very least do something. Inside of the runner, I want from score import the score class. Then we have to create one instance of it, which we can do all the way down here. Self.score is going to be the score, and we need a font. Inside of import assets, I want to get self.score. We only have a single one. This one here, Classica Bold. Load font X. The file name we are getting from join. I want to go to font and then classica-bold.ptf. The font size is going to be 40. Code points is ffi.null. And the code point count is going to be a 0. And I just realized this shouldn't be self.score. This should be self.font. Makes way more sense. The score is the class. But we do want to pass self.font in there. And after we have that, we don't need import assets. Instead, inside of the update method, I want to call self.score.update. And inside of draw, really importantly, after end mode 3D, I want self.score.draw. And now we are getting an error message because I have a typo. This should be update. Next attempt. And now in the bottom right, we have a score. Doesn't look great, but it's a start. I suppose to refine the entire thing. Number one, I want to have the text size. for which we want to have measure text x, so we can use a font, self.font. The text is going to be self.score. And then we have the font size, which really should be a constant font size 40. And this I want to use here. I want to use it here. And I want to use it inside of the import here. Finally, we have the spacing. This is going to be a 1. After that, I want to have a position, which will be a vector 2. For the x position, I want to set the center because that one makes a bit more sense to place, for which I want to get center x minus text underscore size dot x divided by 2. For the y position, I simply want to get self.topy. This one doesn't have to change. Although looking at this, I think a good idea here would be to define a center y and then get center y and subtract the text underscore size dot y divided by 2. That way we are placing the center, which I think feels a bit better. Either way, we want to use the position down here. Finally, we're going to need a rectangle for the background and a line around it. This is still going to be a rectangle for which we need an x position, a y position, a width, and a height. And I want to add padding to it as well, which means the x position is going to be pos.x minus self.padding. Same for the y position, pos.y minus self.padding. And really important now, when we're getting the width, for example, text underscore size dot x, we have to add twice the padding to it because we have to account for the left and the right side. Plus self dot padding times 2. And I guess all of this we should have over multiple lines. That makes it a bit nicer. Finally, for the h value, I guess I can just copy all of this and change the x to a y. That way we are pretty much done. After that, I want to get draw rectangle, round it with the rectangle we have just created. The roundness is a float between 0 and 1. I went with 0.4. Via segments, we can tell how many increments we get to create this. If this is a low number, it would look something like this. And if it's a high number, we would get something like this. Each of those would be a segment. You can basically choose a value that looks good here. I'm going to go with 10. Finally, for the background, we will need a color. In my case, I want 203, 203, 203, and 255. Let's see if this one is working. And this looks pretty okay. Once we have that, I can basically duplicate all of this because now I want to have draw rectangle rounded, lines X, for which we need a rectangle, roundness, segments. Those we already have. Then before the color, we need a line thickness, meaning we need one more argument in here. I'm going to go with 5. And we have to change the color to 102, 122, and 131. And with that, we have a score that looks reasonably okay. I think it should be a bit higher up, but that's an easy fix. I want to get screen height minus 80. Definitely better. Just play around if you don't like it. You can update the position pretty easily. Whatever you prefer. Okay, and with that, we are nearly done. We just have to add inside of get collision. We don't want to print quit game. We want to actually quit the game. With that, if we run into an obstacle, the game should be over. That works. And finally, we need the sound. which is the exact same sound that we have used in the first part. We have jump.wav and music.mp3. Both of those we want to import and play. Inside of the import assets method, I want self.audio. Let me just copy it in. We want to have music and jump, for which we go to audio and then get the file name. Pretty straightforward. Don't forget, before we do anything, we have to init the audio device. Very easy to forget. After that, we have to get the jump sound into the player. That's just another argument. I want to get self.audio and jump into the player class, and then inside of the player, I want to have one additional argument, the jump sound, which I want to store as an attribute. Jump sound is going to be the jump sound. And this we want to play whenever the player presses space. Play sound self.jump sound. That should be it for this part. Let's try. And we get a jump sound. Perfect. Besides that, I want to start the background music. Let's do it at the end of the init method. Play music stream with self.audio and music. Let's copy the value, and then inside of the update method, I want to update the music stream with the same file, and with that, we should be done. Cool. With that, we have the 3D game.